In this section, we will be talking briefly about Splunk user management. So to add a user in Splunk using the native or the local authentication offered by Splunk, simply go to Settings under Users and Authentication and click on Users. Now in here, what you can do, just click on New User and you can do Splunk 3 as the user. This is optional. Email address is optional, and I'm going to provide a password for it. Then I'm going to assign the user role. This is one of the 5 predefined roles that Splunk comes with. I'm going to uncheck the require password change at first login, and I'm going to save that. Now, this is the user that I've just created. By the way, passwords for these users are stored in Splunk Home HC password. Let me show you that. So if we go to the search head under here, and let me zoom in and do VI. And as you can see, we have Splunk, Splunk 1, Splunk 2, 3, and Victor, the use for these users. So let's go back and discuss briefly all the roles that Splunk offers. Now, as I've mentioned before, we have 5 roles. We have the administrator role, and we have the power role, which is privilege with respect to admin and more with respect to user. And we have the user role, which is the least privilege role. Now, let's just discuss about Splunk system role. Now, this one is a very much special role that would allow system level services to run without a defined user context. So imagine when you want to add a search peer, aka an indexer, as part of the search head. So we will be showing that in the subsequent slides. So what does that mean? That means you will create a role or a user with this role under the indexers as well as under the search head. And then you will be adding the search peer, the indexer, to the search head using this role. Of course, you can always rely as well on the admin role, but as a best practice, use the Splunk system role. Now, the role can delete. So when you want to search for specific data on an index and you want to delete that data, the way you do it is that you can use the pipe to delete. This is a special role that it's defined by itself in this dedicated role. So to do that, let me show you exactly what I mean. So let's open a search. Let's expand and let's go to search and reporting. Let me try to find the data in security index. Date range, maybe like up to 1st of February. Do we have any data? Yes, we have some data. What I'm going to do now, I'm going to pipe that to delete. Error. You have insufficient privileges to delete these events. Why? Because we have removed the can delete, role. So what we will do, we will edit that again, and we will add the can delete, acknowledge, save, and then we will try that one more time. And as you can see, we've just deleted these data by adding also the can delete role to the Splunk user. Now, let's move ahead and talk about how we can add a custom role. So to add a custom role, just add a new role you as an administrator, you can actually add a new role. So I'm going to name this custom_role. With Splunk, what you can do, you can actually inherit predefined. So if I do admin, I'm basically inheriting all the capabilities of the admin role. Let's examine that together. And as you can see, next to the capability name, it's inherited. By the way, you cannot uncheck it because you have it inherited from the admin role. But what you can do, you can add more roles to this custom role in addition to the inherited role from the admin. So let's uncheck that and go for the power. And of course, you can see you have less privilege with the power role and you're inheriting from there. Now, bear in mind what we're about to create, which is the custom role, is going to inherit everything, from the power role, as well as wherever it's being inherited at the index level. But it's not going to show under the user interface. And again, you cannot disable inherited capabilities or access when you inherit something from a different or other role. In this case, the power. So you can see I cannot uncheck that. So let's go to indexes. Now, by default, you can see that you cannot uncheck the indexes which are inherited by default from the power role, but you can add others. And also, when you check the default, so for instance, let's check the box for history in here. That means that the default checkbox will define the index that you as a user, you don't specify when you go ahead and search for something. So let's go ahead and actually create this role. So I'm going to create that role. I have just created the role custom role. And this is pretty much showing the inherited capabilities. So what I'm going to do, I'm going to go to the CLI and show you that. So let's go Control X now. Clear. So let's move to cd opt Splunk etc system local and let me show you. So let's do sudo vi authorize, and as you can see, this is the custom role that we've just created, and it's inheriting the power user, the power role. This is exactly what I meant. And this is under opt Splunk etc system local and the authorize.conf. Now let's switch gears and talk about the different authentication mechanism that Splunks offer. So let's go to authentication methods. Now you can rely on authentication based on Splunk local authentication, or what you can do, you can add an LDAP configuration. So you can integrate your LDAP Active Directory of your corporate organization to allow all of these users within your corporate organization to log in to Splunk. And then based on the group mapping, you can assign different roles and capabilities. By the way, I will be demoing that briefly. In the previous section, we discussed user management as well as how to set up local accounts in Splunk. Local accounts are easy to set up when it comes to few users, but it tends to be difficult to manage, especially in the corporate world. Now, to address this challenge, we use a central authentication mechanism to allow the same credentials to log into Splunk and other corporate resources by relying on these directory services. So let me explain this for a moment. As corporations grow, The need to organize user data and assets into a hierarchical structure becomes pretty much critical to simplify storage access of those assets. Now, LDAP enables organizations to store, manage, and secure information about the organization, as well as the users and the assets. The most common LDAP use case is serving as a central location for storing authentication information, such as usernames and passwords, and you can use these stored authentication information on various applications to validate those users. And this is exactly the main reason why we would like to integrate Splunk with LDAP. So we can use these existing AD configuration or Active Directory configuration to add, manage, and update users and groups and assign those groups to the Splunk roles. Now, we already discussed previously about Splunk roles. Now, Splunk comes with pre-configured roles like the admin role, the power role, the user role, and you can rely on those, or you can create your own customized role. So let's jump ahead and show you what it would look like. So this is pretty much the LDAP directory tree. Now, this is your organization, basically. It would be subdivided into different organizations based on the function or the geolocation. Now, these could, the latter, be subdivided into even more groups, or I would call them the OUs, the organizational units. And within the organizational unit, you will have different users also assigned to or member of different groups. And these users typically will have different what I would call privilege access to access different resources, internal resources within this whole, organization. Now, to maintain this in a hierarchical structure is pretty much straightforward and easy. So we will rely on these existing users and the groups to map those groups to Splunk roles. So we will rely on the username and password from these to access Splunk based on the group mapping. So let me show you that. So if we go to this slide, and let me explain that. So you as a user here sitting, and you have a Splunk instance which has been configured to with an LDAP server in the back end. So as you entering the username and the password, the Splunk instance will send a bind request to the LDAP server, and then it's going to authenticate with that LDAP server using the bind DN user. Then the LDAP server will locate that user and it will return it to the Splunk instance. And then the Splunk instance is going to send back that user that you've just entered along with the user to the LDAP server. Now the LDAP server will locate, and based on the privilege and the group mapping of that user, it's going to grant you either a success if the authentication is successful, basically the password, as well as the group is mapped to a role within Splunk, then it's going to allow you to access the Splunk web. Otherwise, it's going to fail. And this is exactly what we will be doing. Now, the steps to integrate Splunk instance with LDAP comprise of create an LDAP strategy and then map the user group to that specific Splunk role. But before we dive into the demo, let's go through the LDAP configuration prerequisites and discuss those, briefly. Now, you will be needing to have the host where LDAP is running, like Active Directory, then the port. Now, typically in production environments, you will be using 636, the SSL, which is recommended. In my case, I'm going to be using the insecure port, which is 389. So no SSL. Now, connection order, in this case, if you have multiple LDAP configurations within Splunk, so you want to order this one as 1, 2, 3, depending on the priority. Now, what is very much important is a service account that has permission to make a bind request, as previously mentioned, to that LDAP server. And it's recommended that you should not use a default AD administrator account, but we will need to create a dedicated account for Splunk with no admin privilege, so we can bind that request to the server, to the LDAP server. Of course, a password. And then we will need to know where to search for these users. Of course, we will need to provide the user base distinguished name. So Splunk could search those users, and of course, the groups associated with these users. So let me show you that. And let's jump ahead to Splunk. So again, let's go to settings, authentication mechanism, and then we will create our first LDAP settings. By the way, I'm doing that via the web. You can also do it through the conf file. So I'll be showing you that as well. So let's create a new LDAP. Let's give it a name. So LDAP 1. Now, in my case, I have the host name. So let me just copy it for a moment. So this is pretty much the LDAP server that I have. I'm going to be using port 389. Now the bind distinguished name for that user. So let's jump ahead to my LDAP server and show you that. So I'm going to be creating a user. I could rely on this one, but I will be creating a user in here. So let's go and do new user. So I'm going to name it as Splunk service account. So I will be just sending that. So Splunk-service. Next, I'm going to provide a password. And then I'm not going to change that. Cannot change it. Password never expires. Next. This is the user. Finish. So that's the bind distinguished name. Let's make it as part of a group. I'm going to do like the security group. So let's check that. Let me check security. Security group. I couldn't find it, so maybe we can put admin. Let's check that. Yeah, we can put it as part of the administrators or admin group. Okay, let's keep it as part of the administrators. Let's hit OK. Done. So now I could rely on here for the user that I've just created. So here you go. I think I found it. So let's go back. There you go. So if we open this one and we go into properties, then this is the distinguished name. So let me just copy the whole thing. Copy. And then we go back and we put it here. And then I will put the password. And then I'm going to be using the user base distinguished name. Now this is the location of your LDAP user specified by the distinguished name of your user subtree. So let's go back to the LDAP. I would like to take pretty much the organizational unit, this one. So this, I want to integrate whatever the users are in here. So let me just do properties and then locate this one. So let me just copy that and go back in here. So I'm going to paste it, or it's good. User attribute, I'm just going to copy the default, which is this one. Copy, paste. Real attribute, this is just CN. So the common name, I'm going to be relying on this attribute. Email attribute, I'm just going to put mail. Group mapping attribute, you can leave that. Now the group-based distinguished name. Let's go back to the LDAP and put that. So the group is this one. So what I will need to do is go to properties and copy this one. So let's copy that. Now let's go back to Splunk, paste it. There you go. Now group name attribute as well, CN static member, that should be member. So as the default value, paste it. And now I'm just gonna save it. So we have saved that. So now, since the first step is done and we have created the LDAP strategy name, so let's go to mapping the groups. So we click on this group. And then you can see in here, these are the LDAP users that we have pretty much imported. So now I'm gonna assign this group, maybe the admin group. So the admin role, sorry. So let's save that for a moment. So now we are done, and you can see that this group name has been assigned the admin role. So now what I'm gonna do, I'm gonna open an incognito window, and I'm gonna use my LDAP credentials for that user. Let's try to log in. It's taking some time, and there you go. So I have been assigned, the admin role for the Sama user account, and I'm able to log in. So let's close this for a moment, and let me show you actually the configuration via the CLI. So let's go to the CLI. So authentication.conf. Let me zoom in. So as you can see here, let me just bring that to the top. Now these are the configurations that we've just entered into the web, via the web, for the LDAP configuration. It's pretty much the same. And as you can see here, the role map for this LDAP, for this group, which has been imported, it has been assigned the admin role. And this is exactly what we have done in here. So what you can do it either via the CLI, and here you can copy paste, and you can see here are the different attributes that we have provided. So the group-based name, the host, the LDAP host, the port, and the user base where Splunk is going to go ahead and search for that specific group, that to search those users under that organizational unit. And of course, under that organizational unit, all the users which are a member of this group, which is part of that organizational unit. And this concludes basically the integration with LDAP. So let's go ahead and install the Splunk Universal Forwarder. But before that, let me show you I have provisioned this Windows machine. Now, normally, what I've done, I went into the wired settings from here. Then on my Ethernet, I have configured to manual and then entered the IP address, netmask, and the gateway. Now, this is one way to do it. The other way, what you can do, so let's go ahead to the CLI. What you can do, sudo nano, let's see, netplan, and then from here as well, you can configure the network settings. Now, for this purpose, what you can use it this way. So let me show you. I'll be providing that as well. So you can configure it also via the CLI. And then once you're done with this settings, then you can do sudo netplan apply. So let's go ahead and first download the Splunk Universal Forwarder. So in case you don't have an account, just go ahead and create, and let's hit on free. So from here, let me log in for a moment. Yeah, Splunk Platform Products. Let's hit on free 60 days trial. And no, this is the Splunk Enterprise. So let's go one step back and to the end of the page, scroll down. Then you can see the Splunk Universal Forwarder. Download it. It's going to take you to the page where there are different flavors with all the supported OS platforms. So let's go for Linux. I'll be choosing the 64-bit, this one, and the the target Z file. So hit on download now. Copy the command. And then let's go to the CLI of the provision Linux system. So before we start, we need to make sure that you have a user. In my case, I've already created that user, but let me show you. So sudo add user Splunk. It already does exist to make sure. So sudo cat etc, and then you can see that this is the user that I've just created. Then Splunk recommends to download and install the Universal Forwarder under the OPT. Let's go ahead, copy that again, copy, paste, sudo. So we are downloading now the file, the package for Splunk Universal Forwarder. Once we are done, it's root. We need to make sure that we need to change this. So sudo chon Splunk, and then the .gz file. I think we changed that already. So Splunk. Now the owner of this package is the user Splunk and the group Splunk. Sudo tar -exit f Splunk. So I think it has been installed already and untarred. So let's change file ownership again, and this time with -r. So it's going to do a recursive over all the files or subdirectories, inside the Splunk folder. hit enter. Splunk. Now let's switch to the Splunk user again. So now what we do is cd to the Splunk Universal Forwarder and do bin Splunk start. Hit Q, accept the license, create a user, and then set a password. Confirm the password by re-entering it. Enter the password again. Authentication complete. So let's do Splunk status. It is running. Now, unlike the Splunk Enterprise, which is a full-blown Splunk instance, the Universal Forwarder does not have a UI. So pretty much you need to deal with it via the CLI. So it is running, up and running, but we have installed it successfully on a Linux machine. I'm using an Ubuntu machine in this case. Now, bear in mind, we've just installed it, but we didn't instruct the Universal Forwarder to monitor no data and no forwarding to the indexer so far. So in the previous section, we have configured the Universal Forwarder. We have instructed the Universal Forwarder to monitor certain files, which is the secure.log and the secure1.log. And we also configured the outputs.conf to forward whatever we're gonna be monitoring here to the indexing here. In this section, however, first we will start to configure the indexer by first configuring it on a listening mode. So it's gonna be listening on 9997 for incoming traffic from the Universal Forwarder. But first, we're not gonna enable this one. We're gonna keep it disabled. So we can see the behavior when we don't have an index for the incoming traffic from here. So let's go ahead and first create this part. And then we will forward the logs. And then you will see the error that on the indexer that you're receiving the logs for an undefined index. But then we will, of course, create that index and then we will redo that again. So let's go and log into the indexer and then configure the inputs.conf so we can make this indexer on to listen on 9997. So let me just delete that part. So now I'm at the indexer. So let's go ahead and change that. So I already have the admin course app created. So I'm gonna go cd local and then I'm gonna go sudo nano. I think I've already created that one. So let me show you that. So nano inputs.conf. And pretty much what I've done, I just copied this part into here. Sorry, not this one. It should be the other one. Into here. So I'm instructing the Splunk indexer to listen for incoming traffic coming from the forwarder. So this is the stanza, which is Splunk TCP. Now, if you guys don't know what is Splunk TCP, so let's go ahead and search that. Splunk TCP. Receivers use this input stanza. This is the same as the TCP stanza, except that the remote server is assumed to be a Splunk instance, mostly like a forwarder. You can still use TCP, : / to activate the receiving side, to listen on that whatever specific port that you want to configure. Also, you can specify the remote server. In my case, I'm not doing that. It's optional. So I'm using actually the Splunk TCP in this case, which I'm instructing the indexer here that the incoming traffic is going to be expected from a universal forwarder. So this is what I'm doing in here. So let's delete that. And let's go back to the CLI. So now that I've created it, so let's go to Splunk indexer. Let's log in. What I'm going to do a debug refresh, just so that we reload the new configuration, which we have just created. So this is done. So now let's confirm if the indexer is actually listening on the port 9997. So I'm going to do ss -an, sorry, and then I'm going to grab port 9997. And you can see in here that, yeah, it is listening on 9997. So let's log in to the Splunk indexer and actually see if we have the index security, because I've just disabled it now. So we actually have it. We still have it. Let me check. Actually, what I'm going to do is, since I have already the indexes.conf in here, I'm going to rename that. So what I'm going to do, so move the indexes.conf to indexes.conf, something like that. So this means that it's not going to be read from the Splunk instance. So let's do a reload one more time. Refresh. Let's wait. And then once it's done, I should expect that this is no more there. Yeah, so the security is not there. Now what are we going to do? I'm going to go back to the diagram in here. So we have already configured the universal forwarder through the inputs.conf to monitor the val log, secure1 and secure.log. And we have instructed also the universal forwarder to forward the logs to the indexer. And we only activated now the indexer on listening mode on 9997 based on the outputs here. Now the indexer security is not enabled yet. If you've seen, I've changed the configuration. So I'm gonna instruct the universal forwarder to forward the logs now, and let's see what's gonna happen. So let me delete that. Let's go back to the universal forwarder. So let's do zoo Splunk, and now bin Splunk restart. So authentication is complete. Let's wait. Put the password again. Let's make sure that it is running. So now let's go back to the indexer. Let's do a refresh. Let's wait. So since we didn't configure the security index, as you can see here, we have received an event for unconfigured, disabled, or deleted index security, which means if we go back to the slide in here, and you can see we have configured all of this, and we have configured that the monitored logs to be sent to the indexer, and the indexer is actually listening on this port, hence we see that event. However, we didn't configure the index. That's why it gave us this error. So to fix this problem, so let's delete this. To fix this problem, what we need to do is we need to actually first enable the security index. So what I'm going to be doing, let's go back in here. Let's go cd opt Splunk, it's C apps admin local. I will just rename this one so it could be picked up by the Splunk processor, and I will reload this configuration so the security index will be shown again. So let's go ahead. I'm gonna do move index to indexes.conf. Let's view nano indexes. Just lower that. Yeah. Hit enter. So this is the security index that I have created. And let's cancel that. Let's reload. So let's go back to here and do a refresh. And let's make sure that the index is going to be shown in here. And in fact, it's here, as you can see. There you go. So now we're back to the index equals security. And as you can see, I'm trying to find the logs because it was showing this error in here. So let's go back to our architecture in here. So you remember we already configured that. The logs has been sent to the indexer, but we cannot see any logs. So here, what we're gonna do. So because we sent the logs and we didn't have the security index in here configured, and I mean by this one, so the data has been lost. So here what we're gonna do, I'm gonna clear the fish bucket on the universal forwarder to trigger this universal forwarder to ingest the logs again. So what I mean by that, let's clear this and let's go to the universal forwarder. So let's zoom in. So cd so let's go and show you actually that. So I'm going to do lsh var lib Splunk fish bucket. You see, this is the fish bucket that I was mentioning in the previous slides. And you see, these are actually, think of it, it's kind of like a database that's going to maintain all the CRCs as well as the data seek and the CRC seek for the monitored files. And as you know, we have 3 files, or actually 2, secure1, secure and .log. And because we've already forwarded these logs and has been already read by the Splunk processor, but we have lost them because we didn't have a security index. So when we're going to be deleting this data, then we will force the Splunk processor to reindex whatever we have configured into the inputs.conf to monitor those specific files. So let's go back to the slide and let me show you what I mean by that. So this is the fish bucket. So what I'm going to do, I'm going to actually take this one. Let's copy this one. And let's go back in here. First, I will need to stop. So let's stop Splunk. So bin Splunk stop. Let's wait for it to Stop the process. Then I'm going to paste. I think I didn't paste it right. So let me try to paste it again. Copy. Index, clear, clean the fish bucket. So let me just put append bin. Yes. Clean event is not supported on this version. Oh, okay. So what we need to do is to actually just to use the remove. So what we can do is remove -R, and then I'm gonna do opt Splunk forwarder var lib Splunk, and then fish bucket. Let's remove everything. Now let's start Splunk again. I am on the universal forwarder. So let's see if it is running. It is. Now let's examine the fish bucket. If it has been recreated again. So opt Splunk forwarder var lib Splunk. Yeah, there you go. Fish bucket. It has been recreated. So now the Splunk processor will go ahead and reread these files. And because we didn't have, when we deleted the database, which is the fish bucket database, which is going to be maintaining the CRCs, and since we've deleted that, so as a first step, it's going to create a CRC for all the monitored files, and it's going to compare it to an empty database. So that is what is going to trigger the reread of all of the monitored files. So if we go back to Splunk, let's give it a moment. It's going to take a while, like maybe a few seconds. So notice now we are reading the files again. So let's go back to our lab. So we have configured this. We have configured this with this. Now, as a final step, we will add the search head as part of the distributed architecture. In the previous section, I have shown you how to install a universal forwarder and deploy it to the Linux machine. Then I have instructed this universal forwarder through this configuration to monitor certain files, which are the secure1.log and the secure.log under the var log directory, and assign it to the index equal security. And then we have configured the universal forwarder to forward these logs through 9997 as a destination port to this indexer IP address, which is this one. Lastly, we have configured this indexer to listen on this port 9997 for incoming traffic from the universal forwarder. And also we have configured the indexer and we have created the security index with these parameters. Now we will go ahead and deploy the universal forwarder on my Windows machine, and we're going to install, first we're going to download from Splunk Base the Windows app or add-on, and we're going to deploy it to this universal forwarder. And then we will also deploy the add-on Windows on this indexer. So we will take care of the parsing, field extraction, etc., as I will show you in a moment. As a final step, once we are done with this, I will be configuring a search head, and we will add this indexer. Let me show you. I will be adding this indexer as a search peer to this search head. So this, the dedicated search head, will enable us to search whatever logs that we have monitored from the universal forwarder on the Linux machine and the universal forwarder deployed on the Windows machine to retrieve those logs. So let's jump ahead to the demo. So let's click on Free Splunk. I'm not logged in yet, so let's log in. Yeah, I'm logged in already. So let's go to Resources, Products, so Free Trials and Downloads. Download a free trial 60 days for Splunk Enterprise. Actually, it is in the previous web page. Let's go to the end of the scroll down, and this is the Splunk Universal Forwarder. Let's download that. So let's go to the Windows section. I'm going to download the 64-bit. So hit enter. Command line. I'm going to take only the HTTP part. Copy. I'm going to paste it, and I'm going to download it here. So once the download is done, I'm going to click on it. I will run it. This is going to show me this wizard. So accept the license agreement. So hit next. Assign a user. I'm going to create my own. Go next. Leave this for the moment. We will talk about this in subsequent slides. Next. This is the receiving indexer. So we have to provide the IP address and also the listening port where this indexer is listening for incoming traffic. So let's go back and provide those. So 10.10.10.10 997. Of course, you can change this whenever you want, depending on your infrastructure. Next, and install. Now remember, in real world scenario, you'll need to take care if there are any firewalls in between, so you need to open the outbound port for 997. The other thing is, we will need to create a Windows index as the next step. So let's wait for this to finish, and then we can jump to the indexer and create a Windows index. Why? Because we want to collect the logs from this Windows machine where this universal forwarder, and forward these logs to the indexer. And of course, we need to assign an index for the incoming traffic. So let's wait for this to finish. So we're almost done, almost through with the installation of the universal forwarder on my Windows machine. So we're done with that. Finish. Let's jump in here and go to the local C to show you where it has been installed under Program Files. And then we go to Splunk Universal Forwarder. Let's hit Continue. You see the directory structure of the Splunk Universal Forwarder under the Windows machine, same as, you know, the one in Linux. So we go under etc, under Apps, and here we will deploy the Windows add-on in preparation to configure it so we can monitor the logs which are generated on my Windows machine to forward those logs to the indexer. First things first. Now we have that installed. What we can do, we can go to services. And then, let me show you that. From here, you can see that the service or the process for Splunk Universal Forwarder is running, which should be under, so let's go further. Splunk Universal Forwarder, there you go, it's running. Okay, so let's jump back to here. Now, let's first examine if we're actually receiving anything from this Universal Forwarder. And I'm talking about the internal logs from the Universal Forwarder to the indexer. To examine that, let's jump ahead. So let's go, first let me delete that. Let's go to the indexer. And let's go to search. Let's check the internal logs. And I'm gonna put the last, I would say, 5 minutes search. What I can do, I'll type it stats count by host. As you can see, this is the Universal Forwarder on my laptop machine, which I have just, deployed to. Of course, this is another Universal Forwarder. This is Universal Forwarder from the previous section, where we have deployed the Universal Forwarder on the Linux machine. And this is how you can see that the Universal Forwarder on the Windows machine is up and running. So let me just click that and view the events. Of course, I'm always putting, time range picker. So these are the internal logs from the Universal Forwarder running on my Windows machine. So why source type matters? So it's very crucial that before data onboarding and before you go ahead and discuss with the customer what kind of data is set to be onboarded, it's very crucial to define a source type for the data to be ingested. Now, source type controls how Splunk formats the data by applying appropriate sets of controls to correctly parse the data into events and allocate timestamp. Splunk comes with a big set of source types defined for many different data types, and you can find that actually under Splunk base. Also, you can rely on the different apps add-ons, as they are also shipped with pre-configured source type serving that data type within the app or add-on. So if no source type is found for your specific data, then you can always create a new one. So many searches, reports, dashboards actually rely on the source type. So Splunk, again, will try to determine the source type for you. If Splunk recognizes the data, then of course it's going to assign to one of the pre-trained source types. So let's take a look at that. So let's go ahead into our Splunk. And then let me show you how we can do that. So for instance, you have a sample data that you've been discussing, with the customer, and you want to onboard that data. So let's go ahead and show you that. So as part of the onboarding, you need to test the data first. So what you can do add data. And then from here to this Splunk instance. So I'm just going to select the file. I'm just going to go for access. Of course, the maximum file upload size is 500 MB. So let's go for next. Again, here, as you can see, we're actually able to rely, because Splunk has already kind of recognized that data, and it has set the source type access combined web cookie. So it actually has basically recognized the data and is going to assign it, the proper source type. So Splunk is doing that for you automatically. And if we click on here, you can see the different categories, so under application, you have the different source types, which comes like shipped within Splunk, email, log to metrics, operating system, for instance, syslog, message format, web, which is this one. Of course, these are the pre-shipped ones. And these are the different source types that you have in here. Of course, we will touch base on these event breaks because these are pretty much instructing on how would you like to segment the data. So for instance, you want to basically ingest the data. And as you want to ingest and parse this data, you want to define actually how to break this data into events. Especially this is very important when it comes to multi-line kind of data. So in this case, you will need to know when it's going to start and when it's going to end. So basically, you need to define the event boundaries, the beginning and the end. And then you can break it so the data should be parsed, correctly. Now, these are the different source type that comes within Splunk. What I can show you as well, so if we go to settings, source types, and in here, you can find the different source types, which are part of the Splunk instance. Anything which is showing as system, these are the default. But take a look at here, config_file. This is part of the Splunk TA Linux. So if you deploy or install an app, which you can always find, under Splunk base from here, and once you deploy it, to the Splunk instance, then automatically you will see all the different source types which are part of that app, and they're gonna land in here, and you can see them. Now let's take an example and show you this. So for instance, I wanna install the Windows app. So let's go ahead, and I think it's this one. Yeah, let's click on it. So I'm just gonna download it first. So let's go ahead and wait for it to, well, my internet connection seems like it's slow. Let me just download it. So accept, agree, and download. So let's go back to here. I don't see any Windows source types, of course. So I can rely on those apps which are found under Splunk base. So it can make my life easier when I want to onboard kind of Windows logs. So I can actually rely on the Splunk add-on for Windows. So let's first install a Windows app or the add-on. So I'm going to go under here, and then I'm going to install app from this file. So let me just do that, upload. So this has been done. So let's go now to settings again. Of course, to make sure that that Windows app is already deployed, let's search for it. So let me just do Control F, Windows, and there you go. We have that Windows Splunk add-on, that has been installed, and of course it's enabled. So let's go again under settings, and let's see what kind of source types have been imported into the Splunk. So I'm gonna choose from here. Where is it? Windows, maybe? Windows. And here you go. You can see we have identified 139 source types, which fall under the Splunk TA for Windows. These are already source types which have already been configured. So you can rely on these. That's going to help you to onboard Windows logs into your Splunk instance. So if we go back into settings, add data, upload data, select file. I'm going to go for the access. Let's go for next. Of course, in here, if I'm going to search for Windows, I'll find now all of these new Windows source types, which are part of the Windows app add-on. So these can really help me a lot to kind of facilitate the onboarding of the Windows logs. Of course, you can always rely on Windows add-on Splunk, where it's going to show you the it's a really good documentation that is going to walk you through the vendor products which are supported by Splunk for these different Windows platforms, operating systems, and of course what kind of source types that are coming within this Splunk add-on for Microsoft Windows. And you can see these are all the different source types that we can find. For instance, I want to search for Active Directory. Let me just copy that. We go back to our source type in here. Let's search that one. And you can see, there you go. This is the Active Directory source type, which is going to help me facilitate parsing the Active Directory logs. So if we go back to here, let's search for perfmon process. Let me just copy that and go back in here and paste it. And there you go, perfmon process. So this is a good way that it's going to help you a lot to facilitate the onboarding process. Now, bear in mind, sometimes there are certain data which you want to onboard and there is no source type defined under Splunk, nor you cannot find it under Splunk base. So what you need to do, you can actually create that yourself. But to do that, then you will need to take care of the event breaks. You need to set the proper boundaries of the event. So you need to know where to break the event to go to the next one, and so on and so forth. And of course, you need to assign the timestamp, etc. And then you can save it as a new custom source type for you. And then you can define, is it at the app system level, like globally, or you can actually create a new app context and you can save all the settings under that app context for yourself. For example, I have already created an admin course app context. So whatever changes I want to do to this source type to actually parse these logs, then I could assign a new source type. For instance, I'm going to call it admin course source type. I'm just going to save it under the admin course app context, and then I'm going to save it in here. So if we go back now under source types, which is under settings, and then source types in here, and then I can select actually my admin course. And as you can see, this is exactly the admin course source type that I've just created. So in here, you can set the, the event breaking policy. So this is a pattern basically to break, into a new line. So we will cover this into as we progress throughout the course. Splunk supports many types of data input. So it can collect the data as an input in so many different ways. And this gives us a lot of flexibility and different options where we can explore based on our infrastructure and how it's set up. And we can choose the best methodology for data collection. So let's first discuss monitoring files and directories. In this option, we can deploy the universal forwarders, whether they are on Windows machines or Linux-based machines. And then we can instruct these universal forwarders basically to monitor certain files that we want and then forwarding them to the indexing tier. So let me show you that. So these are, for example, the universal forwarders. Oops. So these are the universal forwarders. deployed on a Linux or a Windows machine. And then they're going to monitor certain files that we want, and then we're going to send that to the indexing tier. This is one way to do it. Of course, as a best practice, we normally send those logs, from these universal forwarders deployed in here to another universal forwarder acting as an intermediate forwarder. Or what you can do as well, you can send the traffic directly, which is monitored on these end machines, to the indexing tier directly. So let's go back. Now the second option is to receive syslog logs on a port. So pretty much you can configure the firewall, a proxy, or any server to send syslog messages to the either universal forwarder, which is going to be acting as a centralized syslog server, and then the universal forwarder will relay those logs to the indexing tier. So let's go back in here. So here you have a bunch of firewall servers where you can instruct those firewall servers proxies to send syslog messages to an intermediate universal forwarder acting as a syslog server, and this universal forwarder is going to forward it to the indexing tier. Also, you can also send that directly to the indexing tier without having a universal forwarder acting as a centralized syslog server. But this is, as a best practice. So the other way is script execution, modular input, or what I would call scripted inputs. So you can leverage on the OS command levels to actually use those to gather diagnostic data and then send the output to the indexing tier. So what you can do, you can also create your own Python script, because Splunk will also support that, as well as PowerShell for Windows, and you can actually run those scripts on a cron job, schedule time interval, and then forward those generated outputs to the indexing tier. We will go one by one, and I'll create a demo for all of these. Windows logs as well, when you deploy the universal forwarder on a Windows machine, you can, of course, enable it to monitor Win event log security, registry logs, if there are any changes to the registry, DNS, Active Directory, perfmon, to name a few. Lastly, is the HTTP event collector. So basically what you can do, so let's go to the graph in here. So this is pretty much an agentless kind of way of data collection. So you don't need to have a universal forwarder. What you can rely is on an HTTP event data. So you instruct this machine to send those HTTP event logs, to a heavy forwarder, where you're going to have the HEC or the HTTP event collector enabled, and then you can forward those logs, to the indexing tier. By the way, just to let you know, this one here, you don't need an agent. You just need a way to forward those logs. Think of the heavy forwarder with the HEC, on top as kind of an API, and we will discuss this further in subsequent slides. And we will also create a demo about this. So let's go back to the slide. Of course, you can configure most of these via the web, but the preferred method, to configure the above is by directly editing the inputs.conf. So this is how I do it, and of course, I'll be showing you this in the subsequent slides. So let's move on to the next slide and let's discuss. So basically, this is the way to collect, the logs by configuring the inputs.conf here, and the inputs.conf you will configure using the different stanzas. I would encourage you to go to inputs.conf Splunk website, where it's going to give you a lot of info about the different stanzas in the inputs.conf and how you can change and configure those based on the different data collection methodology and the way you can set it up. Of course, there's a very much important thing. Of course, the inputs, it's the way to configure how you would get the data as an input. And the outputs is the way on how to forward the data which is collected at the input and forward it to the next tier, whether it's another universal forwarder acting as intermediate forwarder or directly to the indexing tier. So think of it like a pipeline, okay? Of course, the props.conf is, for data parsing or data manipulation. So pretty much in the data, so this is the data input, which is going to be collecting the data, and in the outputs.conf, it's going to be sending or forwarding the data. In the props.conf is a way on how you can apply the line breaks, to create those events and segment the data. Of course, you can apply some transforms and can manipulate as well the data for data masking. And of course, then at the end, once the data parsing is done, of course, then you're going to go and write that disk. So for data manipulation and data parsing, you're going to be working mainly with props.conf and transforms.conf. So that's that we have covered the inputs.conf and the outputs.conf. I'll be, of course, demoing about those two and as we progress throughout the course. As previously mentioned, Splunk can support different ways on how to collect the data. And depending on the data collection methodology that you're going to be using in your infrastructure, you need to configure the inputs.conf file with the proper settings. So each stanza controls a certain behavior that could be applied on the Splunk instance. So I would encourage you guys to actually go ahead and explore the inputs.conf. As it says here, the file contains possible settings that you can use to configure inputs. So there are global settings which are applied globally, and there are settings which are applied per stanza. So I would encourage you to go through these, and of course I will mention most of the different stanzas and controls that you're going to be using throughout this course. So this is regarding the inputs.conf, and this is for data collection. For instance, you want to configure your universal forwarder to monitor certain files. Of course, then you will need to use the monitor stanza. Or you need to configure, for instance, the universal forwarder here to listen for a specific port. So you will need to use the TCP stanza and so on and so forth. As well as, for scripted input, you will need to use the stanza script. For the HEC, for instance, you will need to use the HTTP stanza. So there are different controls, stanzas that you need to use for serving that specific data collection methodology. Now, this is for the inputs. Now, when it comes to forwarding this data from here to the next tier, then you will need to use the outputs.conf. Of course, I will also encourage you guys, to go ahead and explore a bit about the outputs.conf. Of course, throughout this course, again, I will be demoing and, using one of the most important controls within the outputs.conf that governs the way that you're going to forward the data to the next tier. Now, the props.conf could be useful as well, into the data input. And this is pretty much important when it comes to line breaking, timestamps, regex, transforms, manipulation of the data. So let me show you that exactly what I mean. So let me just delete this and go back to in here. And as you can see, this file possible settings, key value pairs for configuring Splunk. And this is commonly used for configuring line breaking. So for instance, as you're receiving the data, you want to break the data, into events, of course. Especially this is useful for multi-line events. So you need to know the boundaries of the event, the beginning of the event and the end of the event. Sometimes you will need, to configure that manually. Of course, you can rely on the default settings that Splunk offer, but in the end, depending on your data, sometimes you will also need to do that manually. As the data comes in, now some metadata fields are added, and these are the host, source, and source type, and as well as timestamp and index. So let's go to the next slide and discuss the metadata fields. So as Splunk indexes the data, it adds to it some fields automatically and becomes part of the data. And we call these fields as default fields. Now, think of these metadata fields kind of like a way that so Splunk can categorize them properly as part of the data ingestion and then search it at a later stage. So some of the most important default fields are the host, source, source type, index, timestamp. Now, let's discuss those briefly. So let's discuss the host. So the host is like the host name of the machine sending this data as part of the data input. So let's go back in here. So what I mean by that, usually when you have a universal forwarder in here deployed to a machine, that's exactly going to be the host name. So it's going to be present. That's the host name of the machine sending the data. Or it could be actually as well the firewall. So if you, example, you have a FortiGate firewall, in my case, it's a 10.10.10.190, for instance, or an actual domain name, that's going to be the host name of the firewall. So this is equal to the host name. So let's go back and discuss the source. So the source is the originating file name where this data is present when being monitored, or the full path to this file, or for data sent via syslog. So imagine, so let's go back. So for instance, I'm monitoring certain files in here, like under var log, syslog, or var log messages, for instance. So the source is going to be assigned to the var log messages. So it's the originating file where you are actually monitoring that file. Or on a firewall, it could be the host name plus the port number. Now let's go back to our slide in here and let's talk about the source type. So the source type is the way to categorize the data so Splunk can know how to format it. It's like a reference. So it's very important to assign the correct source type. So let's go back in here. So when the data comes in and go to the indexer, you need to find a way to reference this data to a kind of like a point of reference where the indexer is going to assign it a source type so you can actually categorize it inside the indexer. So you can assign the source type either at the indexer, but also you can assign it at the forwarder. So you can assign, a source type, and based on that, it's going to tell Splunk on how to categorize this data so you can search it at a later stage. So now one of you guys is going to ask, what is then the difference between source and source type? So source and source type. So again, the source type is one of the most important fields, and it's a default field that the Splunk platform assigns to all the incoming data. Okay? So that it can format the data during the indexing. Now, the difference is that the source is the name of the file, which is the originating file or the stream, while the source type determines how Splunk software processes the incoming data and then categorize it. Okay? So this is pretty much the originating path or the file being monitored, while the source type is the point of reference that is going to help Splunk to categorize this type of data into the index. And you can, of course, manipulate this data during the indexing to mask some data or to manipulate the data, doing some extraction. And how you will do that, you will need a reference, which is the source type. So in the props.conf, when you want to apply some settings, to manipulate this data or doing some field extraction, then you will need to reference the source type. Of course, you can do that also on the source, but the source type, is always a good reference. The index is where this data is destined for. So as you ingest or as you monitor this data and it's coming into the universal forwarder, or you're just monitoring the data, or simply you're sending this data from a firewall to the universal forwarder, of course, you need to tell the universal forwarder where it's going to be destined for. So what index? So the index is very important. And lastly, the timestamp. So you need to assign, a timestamp to the data being ingested. So now that we've covered this part, let's move on to the next section. Another use case in here is to selectively forward logs to different indexers based on the monitored files. So let me show you that. So we have indexer 1, indexer 2, and we have one universal forwarder. So what we can do is we can selectively, whatever we're going to monitor for the var log secure, only destine this data to indexer 1. Similarly, whatever logs which are under the var log messages, only send it to indexer 2. And we use what we call the _TCP_ routing control. So through this control, we can selectively set or forward the data to the desired indexer. Here's to be configured in the inputs.conf. And then we need to reference that in here. So as you see, TCP out indexer 1. What does that mean is that this is indexer 1. This is the output group, which is indexer 1. And this is the output group, indexer 1. So whatever I'm going to monitor under the var log secure, send it only to the output group indexer 1. Whatever I'm monitoring under the var log messages, send it to the output group indexer 2. So I'm selectively routing different files to two different indexers. So in this diagram, we have a bunch of universal forwarders in here, load balancing the logs to intermediate forwarders. These intermediate forwarders are nothing but universal forwarders. And of course, these intermediate forwarders are forwarding the logs to the indexer. This is typically recommended by best practices to have it this way as a setup. Now, suppose we have another indexer in here. So indexer 2, indexer 1. Similarly speaking, these intermediate forwarders could also load balance the data to the indexing tier. Now, this is very much important when it comes to distributing the events across different indexers. Of course, as well, distributing or load balancing the data from the forwarders to the intermediate forwarders for better data distribution and workload. Now, if one of those intermediate forwarders goes down, this is not going to introduce a single point of failure, as we have another intermediate forwarders, where this universal forwarder could get stuck on this one and then forward the data to the indexing tier. Let's discuss something which is the index acknowledgement. Now, by default, the indexer acknowledgement is set to false unless you enable it. And what it does, let's assume that the data is being sent to the indexer. Now, for whatever reason, there is a congestion, into the network. So there is no way to tell that the forwarder, that the indexer is receiving the data from the forwarder. So in this way, what we can do, we can enable this use acknowledge to true under the outputs.conf. And what this is going to do is basically, if the data get lost along the path, that means that the indexer is not going to send any acknowledgement to the forwarder, which implies that the universal forwarder needs to resend the data back again to the indexer. So this is important because it's going to protect against any loss of data as it goes or gets forwarded from the universal forwarder to the indexing tier. This also could be set up at the intermediate folder. So whatever the data is going to be sent in here, the intermediate folder is going to send an acknowledgement back that the data has been received. And similarly speaking, also from the intermediate folder to the indexer as well. So this creates kind of a better way for data resilience. In this section, we will be discussing the preference to use universal folders over a heavy folder acting as an intermediate folder in a multi-stage data routing design. So let's assume that we have this environment. So typically we will have universal folders deployed to the end machines, and then we will instruct those to forward the logs to the intermediate folder, and then the intermediate folder will forward the logs to the indexing tier. Now, we would recommend normally to use and deploy the intermediate forwarder here as a universal forwarder. The reason why, because the universal forwarder has lower resource impact, scales better, and has less overhead on the wire over the heavy forwarder. If you deploy a heavy forwarder in here, of course, it's going to require a license, and it's going to send the data as cooked, parsed. And this is going to introduce much more overhead on the wire or on the network. While using or deploying the universal forwarder here as an intermediate forwarder is going to introduce, you're going to be using less resources, and I'm talking about hardware specs, scales better, and you're going to be forwarding the logs as uncooked, unparsed. Of course, there are scenarios where you would also want to deploy the intermediate forwarder from a heavy forwarder, and that is normally when you want to introduce, for example, advanced routing capabilities. And of course, if you want, for example, you have a use case where you are sending some sensitive data from these universal forwarders, and you don't want to have that data exposed, on the indexer. So what you can do, you can actually use a heavy forwarder as well to manipulate the data, mask some sensitive data, like for example, credit cards information, prior to writing that to disk on the indexer. Or if you want to activate the HEC, the HTTP event collector, then you will need definitely a heavy forwarder or DB Connect. So these are pretty much the use cases that you would need when you need to use the heavy forwarder over the universal forwarder. But in the end, it all comes down to the architecture design and serving the purpose of how you would like to collect the data versus how much hardware specs or resources you have to allocate to these universal folders or these instances versus how much you're going to be able to scale your design at a later stage. So in this section, we will be discussing the deployment server and why we would need it. So let's jump back to our diagram and explain the reason behind it. So imagine you have this infrastructure or this diagram where you have a bunch of search heads, you have some indexers, and you have a bunch of universal forwarders. Now, as you scale your environment and you introduce more universal forwarders to be deployed to your end machines, the more it becomes difficult for you to manage these universal forwarders, which are deployed on your end machines. So what we can do is we can rely on what we call the deployment server. So the deployment server serves to manage large-scale deployments with hundreds of UFs. We use the deployment server as a central management tool to manage configurations and to be pushed to either universal forwarders or heavy forwarders, which act as deployment clients. So let's go around the naming convention in here. So let's go to our diagram back again. Now, these universal forwarders, we would call them, as we join them to the deployment server, which is here, we will call those deployment clients, which are either universal forwarders or heavy forwarders. And the configuration is done on the deploymentclients.conf. We will go ahead and talk about that briefly once we start configuring and deploying a deployment server and joining the universal forwarders to the deployment server. Apps are deployed under Splunk Home HC apps. So whatever we want to deploy from this deployment server, apps, custom apps, add-ons, we will put those applications, apps, under Splunk Home HC deployment apps directory. And then the deployment server will push those apps to the universal forwarders, and they're gonna land under Splunk Home HC apps. So it's recommended to deploy the deployment server as a dedicated Splunk instance. And this is very much true as you scale up, because normally the universal forwarders, or the deployment clients in this case, will phone home back to the deployment server asking if there are any changes. And this happens on intervals. So management port, it's 8089 both directions. That means, so let's go back to our diagram again. That means that if there is a firewall in between the deployment server and any universal forwarders, you will need to open port 8089 by default, which is the management port, for both the deployment server and the universal forwarder to talk to each other. So you need to make sure that that port is opened on both directions. Let's go back to our slides. So deployment server, again, pushes the configuration bundles like apps, add-ons, custom configurations, whatever you want to configure on those universal forwarders. For example, you want to push a custom app where you want to instruct these universal forwarders to, for instance, monitor certain files in that Windows-based machine or that Linux-based machine, or you just want those universal forwarders to listen on a specific port, or even better, you want to configure these universal forwarders to forward the logs to an intermediate forwarder or to the indexing tier. So how would you go around that? So the easiest way is to configure custom apps, base applications, where you can push them from the deployment server to these deployment clients, which are the universal forwarders and the heavy forwarders. Now, configurations are deployed to deployment clients, which are UF and HFs, under Splunk Home HC apps. So whatever app that you want the deployment server to push to the deployment clients, you need to put them under deployment apps. And those will be pushed to Splunk Home HC apps directory under those UFs, HFs. Deployment clients poll at time intervals by phoning home back to the deployment server. And this is exactly why we would need to open port 8089, so we can enable basically the deployment server and the universal forwarders, or what we call them in here, the deployment clients, to talk to the deployment server asking if there has been any changes or, into the apps directory inside the deployment server. So the deployment server will forward those apps or deploy these apps to the deployment clients. Now, in a moment, we will go ahead, of course, and set up a demo so we can actually configure that and show you how it's done. But before we move ahead, I would like to discuss the concept of how we would reference and assign those applications in here that we want to deploy from the deployment server to the forwarders or the deployment clients. We have what we call a server class. So a server class is kind of a mapping way to map specific apps to be deployed to deployment clients. So, of course, to make those universal forwarders talk to the deployment server, what we need to do first is to create and push what we call a deploymentclient.conf file to these forwarders. And we need to reference the IP address and the management port of this deployment server inside the deployment client.conf. So in this way, the forwarders will talk to the deployment server. And then from now on, then the universal forwarders will start talking to the deployment server, and then you can place whatever apps that you want to push, from the deployment server back to the universal forwarders. This is the way to do it. Of course, how would you then, as a second step, how would you reference or map whatever apps that you have here to the universal forwarders? So this is again what we call the server class. So first we will have a list of our deployment clients, HFs, UFs, under the deployment server. Then we will create a server class, and in this server class, we will reference or we will map wherever desired deployment apps we want through the server class to the desired deployment clients. So we will create kind of a container, a server class, where we will reference the desired universal forwarders that we want to push those apps to from a list of our applications, which are going to reside under the deployment apps. So we will show you that in a moment, and we will go ahead and explain all the steps as we progress throughout the demo. So for the sake of this lab, I have already configured and deployed 2 universal forwarders on my 2 Linux instances. And then I will be configuring and enabling my deployment server on my indexer. Typically in a real-world scenario, when you're facing the customer, and depending on how many universal forwarders that you're going to be managing from the deployment server, it's always advised to have the deployment server deployed on a dedicated Splunk instance. As you scale up, that means you're gonna need more specs. So it's better to have the deployment server run on one dedicated Splunk instance. I do think that for Linux universal forwarders, Linux-based machines, you can actually deploy and manage up to 10,000 universal forwarders from one dedicated Splunk instance where you're going to have a deployment server run on it. So what we're going to be doing as the first step is to configure the deployment client.conf on these 2 universal forwarders so they're going to be able to talk or phone home back to the deployment server. So let's go to our slide and check that together. So configure forward management. So what we're going to be doing is, as a first step, I will be deploying the deployment client.conf on these universal forwarders. And as a second step, I will add the desired apps that I want to deploy to these universal forwarders under etc deployment apps. So I'm going to be placing those here. So let's go to my Splunk Web. So here we go under settings, forwarder management. We click there. So here, forwarder management. The forwarder management UI distributes deployment apps to Splunk clients. No clients or apps are currently available on this deployment server. So what we need to do is, there are two ways. Either we deploy the deployment-client.conf to these universal folders so they can appear, or we can also deploy the applications under etc deployment apps. So let's first, I'm just going to copy. So let's go to the indexer under the CLI. So if I do cd opt Splunk etc deployment apps, here I don't have anything as apps. So that's why we don't see anything in here. So what I'm going to do, I'm going to copy my Cisco app, which I have it here. I'm going to paste it under opt Splunk etc deployment apps. So I need to put sudo. So I've just copied it. And the Cisco app is here now, but I need to change the ownership of this app. So sudo chon -r for recursive Splunk Cisco. So now we have that under Splunk and Splunk. So if I'm gonna do a refresh in here, you see now that the forwarder management has been activated. Repository location is Splunk Home etc deployment apps, which is exactly what we have done. So I've copied the Cisco iOS app. I first downloaded it from Splunk base, and then I've put it in here under opt Splunk etc deployment apps. So this one, this path, which is this path. So Splunk Home, it's basically the global variable for opt Splunk. So now if we go under apps, we see that the Cisco app is there and it's enabled, but it's deployed to 0 clients. So this is the first step. We don't have any server class and we don't see any clients in here. So what I mean by that, we don't see any universal folders. So what I'm going to do now, I'm going to go to my 2 universal folders. So this is the first universal folder. And this is the second universal folder. So what I'm going to do, I'm going to copy, so sudo copy -r opt Splunk forwarder. I have already an app which I've created, which I'm gonna go through it. This is the app. I'm gonna paste it under opt Splunk forwarder etc apps directory. So now we have in here this app that I've just created. So let's examine that. Of course, under this app, we have the local and the metadata. Under local, I have the deployment client.conf. So let's examine that deployment client and what I've done. So sudo nano, it's going to be all local deployment client.conf. Let's examine that. So this is pretty much the stanza that I need to create under the deployment client.conf. And I will be providing this in the course. So this is the stanza. And I'm just referencing here the target URI, which is the IP address and the management port of my deployment server, which is this one, which is acting. So this is the indexer, which is acting actually as a deployment server as well. So let's go back. All I'm doing, I'm referencing and putting the IP address and 8089. So I'm going to save that. And then what I'm going to do, I'm just going to change the ownership of this app that I'm doing. So let's do sudo chon -r Splunk, and then all deployment clients 1 minute. And I will show you exactly what I mean by 1 minute. So let's go to deployment client.conf and let's examine what kind of parameters that I need to provide. So if we go to, this is the deployment client. This is disabled equal to Boolean. We need to actually reference that. So what we need to do is we need to actually copy this one. Now by default, the universal forwarders, let's go in here, phone home back to the deployment server every 60 seconds by default. So we can overwrite that by setting this maybe to 2 minutes, 120 seconds. So what I'm going to do, I'm going to go back to the deployment client.conf file, which is here. And I'm going to change that, as you can see in here, phone home interval in 60 seconds. I can do that maybe 120. But it's really up to you how often you want your universal forwarders to go and talk to your deployment server. Normally, for customers with a large environment and they have probably thousands of universal forwarders and you don't want to put a lot of burden on your deployment server, so you can maybe put that up to every 5 minutes or every 10 minutes. So let's keep that to 60 seconds. So let's save that and go back. And again, this is the target URI. So if we copy that, we go in here so we can have a better idea about what does it mean. So this is the target URI of the deployment server. So for a better understanding of the deployment clients.conf, always you can go back to the Splunk documentation because it provides really a good and a thorough information about the different options that you can set and configure. So that's now that we have configured our deployment client.conf under this Splunk Universal Forwarder. I've already saved it. So I'm just gonna restart my Universal Forwarder. So sudo bin Splunk restart. Once we restart it, then we should wait for 60 seconds and then the universal forwarder here should appear. The first universal forwarder should appear. So I'm just going to refresh, just going to wait for a few seconds. So it's already up and running. So our first universal forwarder just appeared, which is here. And this is the universal forwarder. As you expand in here, you see that no apps has been deployed and there are no server classes associated with this universal forwarder. So let's go ahead and do the same for the second one. So what we need to do is I copy the same. So copy sudo copy -r opt Splunk forwarder all to opt Splunk forwarder HC apps directory. And under here, we have all deployment clients. And then I'm just going to go there, local, and I'm going to show you the deployment clients.conf. So in here is exactly the same. The target URI is my deployment server IP address and the management port, and the interval, the phone home back to the deployment server is every 60 seconds. So what I'm going to do is just change the ownership of that application. So opt Splunk forwarder HC apps and then all. And I'm going to restart Splunk universal forwarder. So sudo bin Splunk forwarder Splunk and then restart. So the settings or the new configuration will take effect. By the way, we can always use btool as a good command to see if the changes took effect. So what we can do is we can do btool and then deployment client, which is the name of the configuration, and then list, and let's do debug. And as you can see in here, these changes took effect. So we need to wait for 60 seconds or more, depending on how fast the universal forwarder is going to talk to the deployment server. Let's do a refresh, and then it should appear here in a few seconds. So now we see that the second universal forwarder also appeared. And this is the IP address, and this is the IP address of both universal forwarders respectively. And you can see this is the host name, this is the client name, and also under here we don't have any apps associated and deployed, because you see here there's 0 deployed, 0 deployed. So now that we have the two universal forwarders for the purpose of this lab, and I have my app in here, what I'm going to do, I'm going to actually deploy another app under the deployment apps directory. So it's going to show in here. So let's go back to our deployment server. And this is here. So I'm just going to copy another file or another app, a custom app, home. I've copied there. So desktop, UF, where did I save that? It's under here. There you go. Then I'm gonna place it under opt Splunk HC deployment apps. So let's check that one more time. And here you go. You have the UF-based inputs. So in this app, the custom app, what I have, so let's examine that. So cd UF local. In this one, I have inputs.conf and outputs.conf. So it's pretty much configurations that I have configured to instruct the universal forwarders to do certain behavior. So if you examine the inputs, so nano inputs.conf, I'm running these scripts. So I'm just instructing the universal forwarders to run the top, the PS process, and the netstat through the script. This is a scripted input. Of course, definitely I need to have also the bin directory where I'm going to be referencing and calling those scripts from the inputs.conf. Also, what we have under the local, we have the outputs.conf. So let's examine that. Outputs.conf. Pretty much what I'm doing is just forwarding logs to my indexer on port 9997. So what I'm going to do, I'm just going to deploy this UF-based inputs also to those two universal forwarders. And I'm going to do that using the forwarder management. So now that we have placed my app under the deployment apps, which is the repository for all the apps that I want to deploy, I'm just going to change that, the ownership, sudo chon -r Splunk UF. So I have both now. So if I do a refresh, there you go. Now I have my UF-based inputs as well and the Cisco iOS app. As a final step, since we have the clients ready and we have the apps, I'm going to associate and map whatever I have here in the apps to my clients by using the server class. So let's delete that and let's go to server classes. So what I'm going to do basically, so let's do a refresh. So let's create one. So I'm going to name this server class, just follow some naming convention that it's going to be easier for you to interpret and make sense out of the server class. So I'm going to call it base, so UF underscore base underscore inputs. Simple. So let's save that. I'm going to be associating the app that I want. So I'm going to put this is as a UF. I'm going to save it. And then I'm going to add also the clients. So how can I add the clients? This is a wildcard. So if I put a star and I do a preview, it's going to take both. So if I do only UF1 and I do a preview, I will be selecting only one UF. So based on this, you can whitelist the ones that you want. So what I'm going to do, I'm just going to also, you can do UF and a star. So it's going to take UF1 and UF2. So there are different ways where you can actually, using this wildcard, to select and match the ones that you want to associate with. In this case, I'm just going to put a star. Just going to do a preview. It's already selected. Of course, you can exclude as well. So let's save that. So now, as you see here, this app is enabled and deployed apps successfully to those two universal folders. So basically, I have deployed this the inputs.conf that I've just shown and the outputs.conf, which is this app under here, this UF-based inputs, to those two universal folders. And if we expand in here, you can see the app that I've deployed and the app that I have deployed. So let's go back to the forwarder management. And you can see now deployed, one app deployed for those two universal folders. So this is one server class that I've created for that purpose. I'm going to create another server class. I'm going to call it Cisco because we want to deploy the Cisco app. And I'm going to call it maybe Cisco app underscore UFs. Just, choose an appropriate naming convention that's going to suit you. So save that. I'm going to add the desired app, which is the Cisco iOS. I'm going to save it. And I'm going to associate whatever universal folders that I want. for the sake of this demo, I'm going to put only UF1. For instance, I'm going to do a preview and I'm selecting only UF1. I'm not deploying this Cisco app to UF2, only UF1. So let's save that. So now we have deployed the Cisco iOS app using the server class mapping to only the UF1. So let's go back to our forwarder management. Now you can see that for the Cisco app UF, if we go to clients, you can see that for the UF1, I have two apps deployed. We expand in here, we have the UF base inputs and the Cisco app. While for UF2, I only have the UF base input. So as a final step, just for verification, let's go to UF1 and UF2. So if we go under CD, if you remember that all the apps that are going to be deployed from, all the apps that are going to be deployed from the deployment server to the universal forwarders, they all going to land under etc apps. So let's do that. Let's go back to the universal forwarder 1 and 2. So CD etc apps. As you can see here, for the universal forwarder 2, we only deployed UF base inputs. While here, let's clear and do CD etc apps. We actually deployed two apps, Cisco iOS as well as UF base inputs. So this is the way on how to manage your apps and deploy them to your universal forwarders from the deployment server. In this section, we will be discussing the different data collection methodology and how we can determine the best option based on our requirements within our infrastructure for data collection. So let's take a closer look at this diagram. So first, what we can do is to deploy the universal forwarders on either Linux-based distribution machines or Windows-based machines, and instruct this universal forwarder through the inputs.conf here to monitor certain files and directories in here and forward these logs through the outputs.conf configuration to an universal forwarder, which is acting as an intermediate forwarder, kind of like a central container, and then take these logs and forward them to the indexing tier. Now, this is one way to do it. And this is the preferred method that I've seen so far with customers. There's also the other way, which is to instruct firewalls, proxies, servers to actually send the event logs as a syslog message to a dedicated Splunk machine. So pretty much think of this as a Linux machine where a universal forwarder is running on top, and then this machine is configured to listen on a specific port, let's say 514, waiting for incoming traffic to be parsed and processed. So the universal forwarder here, which is acting also as a centralized syslog server, is going to forward the logs to the indexing tier. This is the second way to do it. Now, of course, what Splunk can do, we can also create scripted inputs. So on these end machines, what we can do, Splunk offers the possibility that we can pretty much create scripted inputs which run on a scheduled specific time frame through a cron job. And the generated output is collected and then sent to the indexing tier. Think of these scripted inputs like OS command level. So for instance, if we go into here, so if I run top, for instance, like this, so this is the output. So this script enables us to collect this data. Okay, let me just delete this. To collect this data through the scripted input by running OS level commands, and then forward that to the indexing tier. And we will see that in the next slides. Like example, top, PS minus EF, for instance, what are the running processes in the background. So Splunk, you can run with Splunk like shellscript.sh or batch or PowerShell on Windows, as well as Python scripts, which you can do. So this is pretty much a lot of possibilities that we can do. And of course, we will run through a demo and show you that in subsequent slides. So let's go back to our slide and then discuss the other option. Now, the third option or the fourth option is what we call the HTTP event collector. So we will configure a heavy forwarder as an HTTP event collector. Think of this that we're exposing kind of an API, and this HTTP event collector through a tokenized API, it's gonna process or listen for incoming HTTP requests. So this is what I would call an agentless forwarding. So the only thing that you need to take care of is on these end machines, you will need to configure it to send those HTTP event data or requests to the heavy forwarder where we have configured the HEC or the HTTP event collector. Of course, on this one and on this one, we will need to have the same token. So this HTTP event collector will accept only incoming traffic or HTTP requests once we have a token which match the token in here. Of course, these are the different ways what we can do, but also instead of forwarding the logs to an intermediate forwarder, we can also do that directly. So universal forwarders here installed on Linux and Windows machines, and we can forward the logs directly to the indexing tier without having a centralized universal forwarder, where it's going to collect all the logs. The same with the HTTP event collector. We can send it directly to the indexing tier, and as well as from the firewalls, you can also send those to the indexer for data ingesting. So these are the different ways where we can collect the data. What I'm going to be talking next is how we can configure the different options within the inputs.conf as part of monitoring files and directories. So let's go through the first option of the data collection methodology, which is deploying a universal forwarder on a Linux machine and then instructing this universal forwarder through configuring the inputs.conf to monitor specific files inside this end machine and forward the logs to the indexer. For simplicity's sake, I'm going to be ignoring having a universal forwarder acting as intermediate forwarder. So mainly I'll be working with the indexer and with the forwarder. Things as well that I will need you to know prior to this lab is that on this indexer, I've already configured the inputs.conf to listen for incoming traffic from this universal forwarder. And also I have configured the outputs.conf on this universal forwarder to forward the logs to the indexer. I'll be showing you that in a moment. Also, we will create an application or an app on this universal forwarder. So let me show you that. So here I have my universal forwarder, and here I have the indexer. So let's jump ahead first and create the indexer in here. So I'm going to be going to settings, index. I'll create a new index. So I'm going to call it security. Save that. We already have a security, so I'm going to just call Linux. Save that. We already have the Linux here, and it's enabled. So now we're done with that part. Let's go back to our diagram. So what I'm going to do is I'll be creating an app under the universal forwarder, and I'm going to configure the inputs.conf in that app. So let's jump ahead to the universal forwarder. So first, let's go to, let's see, apps. So let me just create sudo make directory uf underscore. So you need to follow a kind of a certain naming convention for this. UF base inputs. Simple. Let's create that. Now under here to the UF base, the structure is you need to create a local and a metadata file directory. So let's do local and create a metadata. So now I have the local and I have the metadata. So before I start to actually create the inputs.conf in here, let's examine the metadata. So let's go ahead into the metadata and let's create local.meta. So what is the local.meta? So the .meta extension files contain ownership information, access control, and export settings, for Splunk objects, like safe searches, event types, and views. Each app, I would recommend when you create it, create always that and do copy the following and put it like this. So you're providing pretty much access, read access to everyone and write access only to admin. And you want to export that to system so everyone, you can declare this as global. So let's save that. So now we have the local.meta. Of course, you need to bear in mind that this is root and we need to change that to Splunk. But let's ignore that for a moment. And now we have local and metadata. So let's go to local and let's create the inputs.conf. Actually, before I want to jump ahead and create the inputs.conf, I would like to show you something. So let me just lslh var log. So let me just expand this a bit. Now you see, these are all the log files of the system level, of this Linux machine, which are all of these. Now what I would like to do is, in the first use case scenario, I would like to create an inputs.conf where I would like to monitor everything in here. How we do that? So let's go ahead and remember, this is under var log directory. Everything in here I want to monitor. How are we going to do that? So sudo nano inputs.conf. So the first thing that I will do, I will create the inputs.conf. So let me just copy and paste. Now this is the monitor, stanza, and this is exactly the the path to that directory, which is the var log, and underneath you will have all the logs that you would like to monitor. So pretty much you're instructing Splunk Universal Forwarder to monitor everything under this. So the index, of course, is not test. As you remember, we have created the Linux index. So I want to instruct whatever you're going to be monitoring under var log, please send it to the Linux index. Source type Linux secure. So let's save that. Now what I'm going to do, we have created this first app. So now I'm gonna sudo change ownership of this file and directory and all subdirectories. So by doing Splunk -r recursive and then UF. So I have changed the ownership Splunk. Now if we do UF, also this. So our application or our app is now ready. Of course, if we go back to the diagram, I've only configured the inputs.conf in here, but I never configured the outputs.conf to forward these logs to the indexer. So let me just do that. So let's delete this, go back in here, cd local. Actually, we need to do cd uf local and then sudo nano outputs.conf. So let's create the outputs.conf as well. Now, this is the TCP out stanza, default group it indexes, and I have also mentioned that in here, and the server IP address is 10.10.10. So it's this one. This is the indexer. So IP address is 10.10.10.10. And I want the destination port to be 9997. So let's save that. Don't forget that it's now root. Of course, we need to do that as well. So sudo chon -r, or without an r in this case, because we want to do that only for the outputs. So the system is ready. So let's go back to the indexer. So I have changed those configurations, but yet I didn't enforce it. So whatever changes I've done to the configuration file, still I didn't enforce it. So I need to restart the universal forwarder. But let's examine the indexer first. So Linux. So I don't have anything within the last 24 hours. So what I'm going to do, so Splunk. So I've changed to Splunk. So let's do restart the Splunk. Restart. provide the password. Stopping, restarting the daemon. Now let's wait. Now to know that even if the universal forwarder is actually sending the internal logs to the indexer, let's go back just to make sure that it is. So let's go to internal. Let's see the host. Actually, we have. So let's, do that the last 15 minutes. Just making sure that the universal forwarder is actually forwarding the logs and we are receiving the log from this universal forwarder. And in fact, we are receiving the logs from the universal forwarder. And as you can see in here, this is the timestamp. So yeah. So we can even do stats count by host in the last 15 minutes. And in fact, this is the universal forwarder that we are receiving. So let me just delete that now. And let's examine if we're actually did that successfully. Are we receiving any logs? Oh, and here we are. So to examine the data, I've done it for the last 15 minutes. The host is the universal forwarder, as you can see. The indexer is Linux, the one that we've created, the processes, sources. So we are actually receiving, but we need to wait for more time. So let's actually do all time. Let's see if we're actually receiving more and more. In fact, as you can see, var log. So let's do that actually by source. So stats count by source. Let's examine that closely. So everything, let's go back to that opt. So var log. So everything in here under the var log directory, as we have instructed the universal forwarder, to monitor anything under this, which are all of these, we are actually receiving those. So let's do a refresh one more time and see. And as you can see, var log, alternatives, auth, cups, dmessage. Where's the dmessage? Dmessage. We are pretty much ingesting, actually forwarding everything under the var log directory. Since we just instructed the universal forwarder to, monitor anything, all the files and directories and subdirectories under the var log, well, that's not a good approach normally. But what if we wanted to actually monitor specific directory? Under the Apache, we have 3 more. So what I'm going to do, I'm just going to copy var log server. And I'm going to go to the inputs.conf in this case. So vi, or actually sudo nano, opt, Splunk forwarder, it's C, apps, uf, local, and then inputs.conf. And I'm going to change this. Why it's not really saving that. It's not pasting it. Okay, so var log. Let me remember if I'm getting that right. Apache-web server. Let me just save that for a moment. Is it Apache web server? Yeah. So var log Apache web server. Let me make sure. var log Apache web server. Now, I want to monitor actually these only. Whatever, files or directories under the Apache, I want to monitor that. But since we've already ingested that, and we can see it under here, so what I'm going to do, first, I'm going to use the delete command to delete everything in here. So I've deleted all the logs. We don't have anything anymore. But also I need to, remove the fish bucket in here. So let me just first save that. let's go and stop the universal forwarder. Bin Splunk stop. Let's first stop it. Let's wait. So we have stopped it. Now I'm gonna cd to var. It should be var lib Splunk, and then there you go, the fish bucket. So I'm just gonna delete everything in the fish bucket. So I'm just gonna do remove -r recursive fish bucket. I just removed everything. Why? Because I want to re-ingest the same data again. Remember, we already monitored everything under opt under var log. So we are not going to be able to ingest that again unless we clear the fish bucket. And if you don't know what's the fish bucket, please go through my previous slides so you'll understand that. So I want only to have the Apache web server in this case. We've already configured the inputs.conf, to monitor only at the Apache web server. So now that I've deleted pretty much the fish bucket, so I'm resetting everything. So what I'm going to be doing now, let's make sure that we don't have anything. What is this logs? Yeah, this is fine. So we can also delete this. That's fine. And now let's go back, index equal to Linux. We have nothing. So let's examine one more time what I'm going to be doing. So nano etc apps uf and then local inputs.conf. So I'm instructing the universal forwarder to monitor everything under var log web server. So now let's start Splunk again. Actually, it's already stopped. We have to start it. Let's check status to make sure that it started. Yeah, and it is running. Okay, so let's see. It's going to take a while. Let's wait for a few seconds. So I've restarted the universal folder so that the configurations, take effect that we've just made. Let's go to the index, Linux, and let's see what kind of logs now I'm having. So let's go for all. And in fact, if we go under the source, you can see that we are only now monitoring var log Apache web server and all the subdirectories. So this is exactly what we have done in this scenario. So let's take another use case. So let me just go back to the universal folder and let me show you. So we are under the var log with all the files and the directories where we have the logs. And let's take this use case. So tree Apache web server. Now, as you can see, we have server 1 with all the logs, which are access and secure.log under Apache, which is a subdirectory under Apache web server. And we have the server 2 and the server 3 directly under Apache web server. Now, I would like to only monitor server 1, server 2, and server 3 with all the logs. Regardless of where server 1, on how many subdirectories it belongs to, I would still want to monitor anything with server. So how we can achieve that? So we have something with Splunk where we can specify input paths based on wildcards. And we have two basically controls or settings. The first one is ellipses. So let me just show you that. And this is a nice document. So we have the ellipses wildcard and we have the asterisk, wildcard. So the ellipsis wildcard searches recursively through directories and any number of levels of subdirectories. And this is exactly what we want to achieve in here. So server 2 and server 3 lies, beneath Apache Web Server directly. But server 1, there are multi-layers, of directories, or let's say there is still a subdirectory of Apache. So how we can do that? So when we use the three dots, we're actually doing a recursive over whatever, subdirectories until we reach server 1. So let me show you that. So let's go sudo, actually without sudo. So nano, opt, Splunk forwarder, etc, apps, and then UF, which is our app that we've created, local, and then input stock. Now, as you can see in here, let's jump to this one. So what I would like to do is I only want to monitor. So let me just show you that. Opt var log. So let me bring this Apache web server. So I only want to monitor, for example, the access log and either, so the star in here, the asterisk, is pretty much a wildcard. So which means server 1, server 2, server 3. And I only want to monitor access.log underneath in this path. But also I have included the three dots, which is the ellipses. So do a recursive until you find server star, which is server 1, server 2, server 3. No matter how many subdirectories, along the path, search server 1. So that means there is Apache, still go one level down until you reach server 1, server 2, and server 3. And this is exactly what we want to do. So let's delete first this one. I don't need it. And let's save that. And now let's make sure we don't have anything in here. We don't. So I'm just gonna do cd opt Splunk forwarder, and then bin Splunk restart or start. I've already cleared the fish bucket. So let's restart it. And let's wait for this to happen. So what we have instructed the universal forwarder is to do, a recursive search until you search and find server 1, server 2, server 3, and only along the path find me the access.log. So let's go ahead and search our index again. Let's put it to all. And voila, we found some logs. So let's take and examine this. So under the source, in fact, if we put this, so let me just show you. So where is it? In here, we can see that we're only instructed the universal forwarder to monitor access.log from server 3, server 2, and from server 1. Take a look here. Log, Apache web server, and Apache, which is exactly what we have done in here. I would encourage you guys to go ahead to this website, and it has a lot of different examples where you can experiment and do some tests. Now, let's examine again the logs. Now, as you can see in here, the naming, I don't want to include actually the whole path. Maybe I want only to include server 3, server 2, and server 1, which is gonna imply that these are the logs, belonging to server 3. So what we can do, so there's another option. What we can do is to add here, and I've already mentioned that before, which is host underscore segment. Now, what we can do is, now, if I put number 4 in here, and that means I will take as a host only the 4th name into the path. So let's examine this. So 4, which means 1st, 2nd, 3rd, and 4th. But you'll see in a moment why this is not, gonna work well, because maybe it is good for server 3 and server 2 and server 3, but then we will have Apache only along the path. So let's do this change, and I'll let you know what we can do. So first, let's delete the data again. And by the way, notice this is host UF. So let's delete first the data. So now we don't have anything in here. Now let's clear the fish bucket. So let's stop first the universal forwarder. And then let's wait for a second. And then let's clear the fish bucket so we can be able to reindex and instruct the universal forwarder to look for those files again. So let's clear the fish bucket. By the way, this is a complete wipe, of the whole fish bucket. Let's start Splunk universal forwarder again. Supply the password. Done. Let's wait for this to happen. So it's going to take some time, until the universal forwarder is going to go and look for and monitor all of these files and put them into monitoring mode. So let's search the data again. So index equal to Linux, and let's put all time. And now, as you can see, we have assigned them the name server 3, server 2, and Apache, because we have chosen host underscore segment to the nth name in the path, along the path. So that's exactly what we have done. So let me show you again. So host segment to be assigned is number 4. So along the path, the 4th one would be. And actually, we can go to the inputs and show you what does that mean. So Control F, host underscore segment. If set to n, then a Splunk platform sets the nth separated segment of the path. So it's the 4th, portion of the path is going to be assigned. But now we are facing another problem. What if the server is on a different subdirectory? And that's why we're having Apache in here and not server 3 or server 1. So let me show you that again. So in here, we have server 1, but since it's the nth or the 4th segment portion, so 1, 2, 3, and 4, which in fact we want the right one. So how we can fix this? Now there's another way where we can do is, so let me first take this all. And let me just go in here. Actually, we have it already. But let me just delete this. And then var log Apache web server server 1. And actually, I can paste the other one. And it was Apache, then server 1 slash whatever access.log, etc. So I'm going to change this to 3. So the other way, what we can do, instead of host segment, we can do it with regex. So host regex equal, and I think we have it already in here. So let me just find it. So host underscore regex. There you go. So if specified, a regular expression extracts the host from the path of that file. Now, you need to be familiar with regex, how to use regex. So I would put a link so you can get an idea on how to use regexes, because they are crucial to Splunk. So let's create a regex only to extract the server name. So what we can do basically this. So how we can do that? Because what we're going to do with this regex when we are, setting this control is to go ahead and look in here for whatever into the path and look only for the desired, regex match. So how we will do that? So let me just skip this. Then let me put server and a \d, which, means a digit. Then I will need to round this with a capturing group. So it should be something similar to this. So it's pretty much taking the capture group, server 3, server 2, and server 1. We copy this. Then we paste it in here. So let me save that. And now we need, of course, to repeat this test again, delete. We have deleted everything. Let's stop Splunk. Take it a moment. Clear again the fish bucket. Of course, there's a command where you can specify to clear using the fish bucket for a specific file. But for simplicity, I'm just going to delete the whole fish bucket directory. There you go. And I'm going to just start Splunk Universal Forwarder again, so we can instruct it, to go ahead and monitor those files again. So let's see what's going to happen. So let's paste it again and do a search. Okay, no, it's 24 hours. Let's put it all. So guys, take a look. Let's see what's going to happen. So did that change or not? And yes, server 1, server 2, and server 3. So we fixed that issue. So what we have done, we have used a regex match to go through, these are the paths that we want, and we want to only extract a specific segment of that path. And this is exactly what we have done. And we have copied this and we've put it under host regex. So I really encourage you to go through this documentation in here and, do some tests. So let's take another example. So first, let me just clear that and delete everything from my index. So it's not searchable. By the way, even if I use the delete command in here, that doesn't mean it's gone from the index. You need to go physically and delete the data as well. So you can do the clear data, the clear index command. So let's take another example. So what if I would like to monitor or whitelist only the access.log in here from server 3 and server 2, not this, or the secure.log. Let's go with the secure.log. What can I do? So let's first stop Splunk. And then let's wait for a minute. Okay. Then let's go and clear the fish bucket. And let's go back to our inputs.conf. So I would like to monitor only the secure.log, whitelist only the secure.log from server 2 and server 3. So what I can do. So let me remove this Apache web server. Let's keep the star. Well, actually, what I can do, I can do it this way. And then I want to remove the host regex. And I want to put something different, which is whitelist. And I want to whitelist only the secure.log. Or actually, I could take another example. So do we have another example where we can use in this case? Actually, I found something. So I want to whitelist only those. How would I do that? So first, let's go to the right directory. So var log in this case, because we are under the var log, as you can see, tree var log. And then I want to whitelist only those. So how I would do that? So first, let's copy those. And let's go to our regex 101. Let's paste that. So let's try to work that out. So I will start with underscore server \d for digit, and then backslash, a dot because I'm escaping the dot, and then a log, and then I'll put a $, which is end of the file. So what I can do here now, I will just copy this. So I'll just copy this and I will paste it in here. But this is going to be only for monitoring purposes. What if I want also to name the host according to the logs? So if you remember what we can do, we can still use the host underscore regex. So let's check that one more time. So what we can do, let me remove everything from here and type Apache underscore prod underscore, and then I'm going to put capturing group server \, I'll put a D or maybe a dot and a star, but then I'll put a \dot and then log and then the $, which is end of the file. So I'm capturing, I'm just matching everything, but as between these group, I'm just capturing the exact. So I'm using a capturing group to only take the server 1, server 2, server 3. So this is a match, and this is the exact group. So let me just copy this. I'm going to copy it. I'm going to paste it in here. Now I'm going to save that. And let's start Splunk. So let's wait for this to finish. So to recap, I had to restart Splunk twice for this to take effect. So let me recap with you guys what I've done. So let's bring back that. So under the var log, monitor var log, but only whitelist, and this is a regex match. Just go through the var log and find anything that matches this regex. So in this case, it's gonna match this one. And then assign those with the host underscore regex equal to this. And the capturing group should be server 1, server 2, server, whatever server number, a digit. So I'm taking this portion, using the capturing group. Again, I encourage you to go through the regex tutorials. So let's go into the index and examine that. So let's see. So if we go to the source, exactly what we have done, we have only whitelisted whatever is matching here. So if we go back into the regex, I'm matching those. So monitor these files. So this is what we are doing in here, whitelisting based on a regex match, which are those. And then using the host regex, and then extract server 1, server 2, server 3, server 4. And this is exactly what we have done in here. So you can see server 1, server 2, server 3, server 4. Now that we're done with the monitoring input, which is this part, I will go ahead and configure a firewall to forward the logs to the universal forwarder. So first, there are a few steps that we need to take care of. I will need first to create an index in here. Now, for the sake of this lab, I'm gonna be configuring a FortiGate firewall and send those logs to the universal forwarder. But first, I need to create the FortiGate index under the indexer. And then under the universal forwarder, of course, I will need to configure it to listen for incoming traffic on a specific port. And then lastly, I will instruct the firewall, which is the FortiGate firewall, to send those logs on that specific port, which the universal forwarder is listening on. So first things first, let's go ahead and configure that. So first, let me just delete this. Let's go to the Splunk and let's go to indexes. I think I have already created the FortiGate, so it's here. What I'm gonna do, I'm just gonna delete it. I'm just gonna recreate it one more time. So let's go ahead. I'm gonna put FGT FortiGate firewall, keep everything as it is. I'm gonna save it. The FortiGate, index is there and ready. So now we are on the universal forwarder. What I'm gonna do, I'm just gonna delete everything. I'm just gonna Control X, save it. Now, I would like to send or to make this universal forwarder to listen on a specific port. So let's say 55555. So let's go ahead and configure this universal forwarder to listen on that port. So what I'm gonna do, actually, before I'm gonna do that, I'm gonna check if this universal forwarder is listening on any port. So I'm gonna do 555. So for now, I don't have any, the port 4 times 5, the universal forwarder is not listening. So what I'm gonna do, I'm gonna go back to the inputs.conf and I'm just gonna copy this configuration. So basically what I'm doing is, using protocol UDP, I'm instructing the universal forwarder to listen for incoming traffic on this port. And whatever traffic is going to be picked up from this on this port. I want to reference it with the index equal to FGT. I want to assign it with the source type FGT and the source FortiGate. Now, connection underscore host. Now you have different options. You can do DNS. So the Splunk will do a reverse lookup for that IP, if it's an IP, to actually get the domain name. Or I will just keep it to IP. Queue size, more to come about this, and then disabled equal to 0. So I'm just gonna do and save that. And I'm gonna restart the universal forwarder. So let's do, okay, so zoo Splunk cd opt Splunk forwarder, then Splunk restart. So let's just start Splunk for a moment. Okay, so let's run that ss-an. I'm gonna grep for that port. Let's see if it's up. And in fact, as you see here, by doing the configuration under the inputs.conf, now my machine where the universal forwarder is deployed to, I've instructed it to listen on port 5555 for incoming traffic. So let's go back to this. So what I've done, I have configured the index FGT here. On this universal forwarder, I have configured it to listen on 4 times 5, so 5555 on using UDP protocol. Of course, it's already, this universal forwarder is already configured with the outputs.conf to forward the traffic to the index, the indexer. Now comes the and we have verified that the port is up and running by checking here, this one. Make sure in real world scenario, you don't have any firewalls in between, just to make sure that the traffic is sent. And then I'm going to go to the last part where I'm going to configure that FortiGate firewall to forward the logs on that port, which is 4 times 5 UDP protocol. So let's jump ahead and do that together. So let's jump to the firewall. I have a FortiGate firewall in here. And I want to configure this FortiGate firewall to send the traffic to the universal forwarder on port 5555 using the UDP protocol. So let's go to log and report, log settings, and in here, so remote logging and archiving. I'm not using any FortiAnalyzer or FortiManager. I want to send those logs to a syslog server. And the syslog server in here, in our case, is the universal forwarder, this one. So let's go back to our FortiGate, and there you go. I'm gonna enable that. So I want to send the logs to 190, or actually 60. I'm not sure. Let me just check. IP address show. So my IP is 10.10.10.60. Yeah. So let's go back. This is the universal forwarder, by the way. So let's go back. This is 60. Event logging, local traffic, everything is set. Let's apply. So settings are done. So we have configured the firewall. Let's go ahead and see if we're actually capturing any traffic sent from that firewall. So what we can do is we can use TCP dump -i any. So this is the flag for any interface. And I'm going to do, for instance, so before -i any, -n. And I'm going to do minus double V. Then I'm going to specify the port to be 555. Okay, we need to do that with sudo. So I'm listening now. So let me just log in, admin. Let's see if we are receiving anything. In fact, we are receiving. So if you can see here, I'm sending from my firewall, which is this one, the FortiGate, from this source port to my universal forwarder on this destination port. So I'm receiving. So basically, if we go back to I'm sending it from this firewall to this. Now we've already configured the inputs, to listen on 5555. And then the universal forwarder here is acting as a syslog server. It's going to forward the logs to the indexer. And we can see that into action. So let's go back to the search. Index equal to FGT. And let's search for the last 24 hours, or actually the last 15 minutes. And here we go. So host, it's exactly this one. But take a look. The host in here is the firewall, which is this IP. Index is FGT that we've configured. This is the source, which is the FortiGate, and the source type, which is FGT. So this is pretty much how you configure and forward the traffic from a firewall to the to the universal forwarder listening on a specific port. So now that we have configured this firewall, the FortiGate firewall, to send the traffic syslog messages to the universal forwarder, and the universal forwarder through the port 5555, and then it's going to relay whatever being received from here to the indexing tier. But let's talk about this configuration that I've done earlier, which is the queue size. So how can this help us? In Splunk, we have what we call flow control. So these queue settings in here provide kind of a flow control across the entire input stream. So imagine this firewall is sending too much traffic, bursts of traffic to the universal forwarder. Now, remember, this data in here is in transit. If it's not going to be processed by the universal forwarder, it's going to be lost. Now, for whatever reason, maybe the resources, the hardware specs of this universal forwarder is not up to the data which is being received from this firewall. So some of the data will be dropped. So what you can do is you can configure this universal forwarder through the inputs.conf with the queue size to actually buffer this data into kind of a queue. And this is the queue size. I've configured to 10 MB. Now, as soon as the universal forwarder is able to process everything, then it's going to relay the traffic to the indexing tier. Another scenario. Let's suppose the indexer is not there, is not reachable by this universal forwarder for whatever reason, a congestion on this network, or just down, whatever. It could be many reasons. Now, the universal forwarder is going to see that this indexer is not reachable. So what is it going to do? So the universal forwarder in here is going to buffer this data again into what we call the memory queue. Now, if the memory queue is full, then we can fall back to what we call the persistent queue. Now, the persistent queue is going to write the data which is in transit, which is not being able to process it from the universal forwarder. It's going to write it into disk under the var run Splunk directory. As soon as this indexer is reachable, or there's no more congestion into the network in here or here, then the universal forwarder will start process this data and is going to forward it to the indexing tier. Now let me show you that. So let me just bring the configuration in here. So the queue size is the maximum size of the in-memory input queue. Default is 500 KB. Of course, you can configure it with KB, MB, and gigabyte. Persistent queue is the maximum size of the persistent queue file. Persistent queues can help prevent loss of transit data. Now, this is what we call on the input size in here. Now, this should not be confused with what we call the max queue size. So this is also the same concept, but this is applied at the output queue. So the output queue is in here. So let me bring that 1 second. So if the indexer cannot keep up with the data, this is going to be useful on both sides, whether it's an issue in here or an issue in here where the universal forwarder cannot keep up with the burst of data which is being received at this end. So in this section, I'll be discussing the scripted inputs. So Splunk can execute scripts based on a scheduled time, a cron job, and of course index the output. So let's go back to the universal forwarder and let me show you what kind of commands that we can actually schedule to be executed. So first is like PS minus EF. You know, this is just to give you the internal processing, basically the processes which are running on my Linux machine. Top, for instance, time, uptime. You have different OS level-based commands. So we can rely on these scripts so they can run on a scheduled interval on our end machines. So on Splunk base, there is a very good app where it offers really out-of-the-box scripts that you can actually rely on, for testing purposes. So just go ahead and install and download the Splunk add-on for Unix and Linux. And I'll just break it down for you, the directory structure. So normally, for a directory structure for the scripts, they live under the bin directory. So all the scripts, they have to live under the bin and they have to be called from within the bin directory. So let me show you. So let's go to this Splunk TA for Nix. And under the bin, you can find all the different scripts, the shell scripts, where we can run these OS commands for our Linux-based distribution. For example, interfaces, PS, top, to name a few. So if we go back to our universal forwarder, the way it has to be done is as follows. So let's go to, let's see, apps. We already have the app set up in here, which is the UF-based inputs. Now in here, I have created the bin directory. And under the bin directory, I have copied some of these scripts. So I've copied the common. Of course, this is very important. And I have copied the PS, the top, and the netstat. So let me show you. So ls, lh, bin. So I have these three commands, of course. Now, for you guys, if you want to wonder what is the common.sh, this is pretty much to set the global variable for some of. So this is going to serve as an input for the netstat.sh and the ps.sh so they can run smoothly. So how we would call these scripts. So of course, we will need to define that under the inputs.conf. So let's go ahead to the local, then sudo nano to the inputs.conf. And as you can see here, this is the stanza for the script. And I'm calling the ps.sh, and I'm giving it an interval to run every 30 seconds. And I'm assigning a source type of PS and a source of PS. And I am also sending whatever is the output would be generated from running this script to be targeted for the Linux index. Same with the top, same with netstat. Control X. Now, to show you, I have the bin directory, and these are all the shell scripts where they have to live. And under the local directory, I have the inputs.conf, where I'm going to be instructing to call the scripts which are under the bin directory, which is exactly here. So I have the bin, and I have the default. In our case, I have the local, and here I have the inputs, which is going to call whatever scripts that I have under the bin directory. Now remember, all the scripts under the bin has to be executable. So let's show you that. cd bin. Of course, they are executable. So let's go to our search and let's find out. So Linux. And I'm going to call it for the last 15 minutes. And as you can see, I am pretty much receiving logs from the executed command ps, top, and netstat. Of course, these runs on a scheduled interval. This is every 30 seconds, this is every 60 seconds, and this is every 60 seconds. Now, to show you as well, under the indexer, I've already copied as well the whole TA, and let me show you. This is the TA, Splunk add-on for Unix and Linux. You can also have a representational view of all the commands, which are part of this TA. So let's go to data inputs. From the data inputs, you scroll down to scripts. And underneath the script, just click on app. And as you can see, these are all the different commands which are part of the Splunk _TA_nix, which is this one. And here shows under this column, interval column, shows you they are running on an interval of 60 seconds, 360. So this is a really good start where you can make use of some scripts which are offered in many TAs from Splunk base, and you can customize it to serve your purpose. So in this section, we will be discussing about the Splunk HTTP event collector. So the Splunk HTTP event collector has gained a lot of popularity in a world that has been shifting more into the serverless and the cloud native side. Of course, there is no need for a package installation on the client side, which means you don't need an actual universal forwarder to forward these HTTP event data to the HTTP event collector, because it's using pretty much a well-recognized protocol, which is the HTTP, and it's known for being scalable, secure, and above all, it's token-based for convenience and easy to maintain. Now, let's discuss more about the HTTP event collector in here. So the HTTP event collector, think of it like API, which is exposed on the Splunk side. Now, HTTP event collector normally would accept either JSON format logs or raw data. So we have two endpoints in here, which is the services collector event for JSON format, events, and the services collector raw endpoint for raw data. So the HTTP event collector is an endpoint that lets developers, send application events directly to Splunk via HTTP or HTTPS. So that means you don't need a universal forwarder because it's agentless. So a developer can use, for instance, a C URL, or curl, basically, to actually send those HTTP events, to the HTTP event collector. Now let's walk you through that. Now it's a token-based, either HTTP or HTTPS for authentication. It sends the HTTP events directly without the need for an agent. Now pay special attention in here. HTTP event collector cannot accept your data unless the HTTP data is authenticated. This is done by having the token in the authorization header of each HTTP request. So as you're sending those HTTP event data, you need to provide a token which matches the same token which has been configured in here. Otherwise, the HTTP event collector will drop those events. And we can see that momentarily, in our simulation here. So this is what we're going to be using. This is the curl command that we will be using. And I will break it down for you so we will understand more on how we can basically use the curl command to forward those events to the HTTP event collector. So let's actually jump ahead and configure basically the HTTP event collector on Splunk. So let's switch to my admin course. It's just an app context that I've created. So let's go to settings, data inputs. We scroll down, this one. Now, here says all the tokens are currently disabled. They can be enabled in the global settings. So first, what we need to do is to enable the global settings for HTTP event collector. So let's click on that. Let's make sure that it's enabled. We're going to go and accept JSON format. Now the default index, I would go for main. Now for the default output group, so think of this. Okay, let me just show you into our diagram. So this comes into play when you sending those HTTP event data to your HTTP event collector. Now, typically in a distributed environment, maybe you want to collect those logs in here on a Splunk endpoint like a heavy forwarder, but also whatever you're going to be collecting from here, sending it to an indexing tier. And this is exactly what it means by output group. In my case, I'm using a local machine, so I'm not going to enable the SSL, so I'm going to keep it as it is. I'm going to use the HTTP port 8088, and I'm just going to save it. So now the global settings has been done. I'm going to go ahead and create a new token. So I'm going to call it admin course. This is completely optional. So source name overwrite, I can do that as well. So I'm going to call it heck admin course. So I'm assigning this to the source. Description, I'm going to leave it optional. This is again the same output, output groups. So I'm going to leave it to none. So let's go ahead and hit next. I'm going to leave that to automatic, and I'm going to use the main index as the allowed index. This is the default as a last resort. Let's review that. So this is the input type, the HTTP input type, and this is the name that we have assigned. This is the source overwrite. Of course, the allowed indexes is main, and this is the default last resort. So, and this is under the app context, admin course, which is this one. So let's submit that. And this is actually the token that I have generated by enabling this HEC endpoint. Now, this is in the GUI. Let's show you guys how that would look like under the configuration. So what I'm going to do, I'm going to use actually btool to show you how could btool help us, to determine where we have configured those. So let's do bin Splunk and then btool help. So I could use this, to help me configure, to write the right command. So btool inputs, because I'm going to be looking at the inputs.conf file for all the configurations within the HTTP event collector. Of course, I don't need to provide the .conf extension. I'm going to go for list here. The stanza is HTTP. And then I'm going to do minus debug, hit enter. And as I can see, the configurations for the HTTP stanza that we've done for the global settings. So let me show you. Let's go to data inputs, HTTP event collector, global settings, and I mean those would be located under here. So nano. And this is exactly what we've configured. So HTTP, so it's enabled now in here. As you can see, it's enabled. I'm using the index main, source type is JSON, and enable SSL is set to 0 because it's disabled in here. So let's exit. And let's actually check also the settings, that we've done here under the GUI and see it under the conf file. So as we see, it's here. So let's just copy that. Nano, hit enter. So as you see, it's enabled. It's index main. Allowed indexes is also main, and this is the source override that we've done, which is here. And this is the token that I'll be using basically in here in my my curl command, so I can forward the HTTP event data to the HTTP event collector. So I'm gonna change this one. So let me just remove this part and then copy this whole curl command and then run it. So if you see, this is 394, this is 394. So I'm using this token because on both ends needs to match. So let's go to here and let's run that curl command. Copy, paste. Of course, let's break it down. So curl -k, that's the curl command. In case you don't have the curl command, you can do is sudo apt install curl. So that's the curl command. -k to skip a certificate check. And then this is the actual host and the default port. And if you see here, this is the endpoint, services/collector/event. This is the endpoint, services collector event, which I'm going to be calling for. And then into the header, I'm going to provide the authorization. Always provide Splunk as identifier prior to the token. Now this is the token that I'm going to be providing, which matches this one. And then -d for the data payload. And this is a source type of -JSON. And the events, I'm going to be creating a field value pair. So this is kind of like a JSON format. So let's hit enter. And as you can see, it's a success. So let's go back in here. And actually, let's go into the search. Let's go to admin search from here. And let's hit index equal to Linux. Was it Linux? No, it was main. And here we go. So now, if you see, I have created a field 1 of value 1, field 2 of the value 2, host, which is the indexer, with the port 8088, which is the heck, which is listening on this port. I have the source overwrite, which I've just defined under the settings into the heck configuration. And I have the source type -JSON, _JSON. So this is exactly what I've done. Now what I'm going to do, I'm going to change the values, maybe value 2, or actually value 3, field 3, value 3, field 3. Let's hit enter. Let's search again. And here we go. Now we have field 3, value 3. Field 2, you know. So pretty much this is what I've done. And of course, what we can do as well, let me change actually. So let me just put 4. Let me change that token and maybe make it like, instead of 4, I'm going to put a 5. Hit enter. Invalid token. Why? Because this token now does not match the token that I configured this heck with. So there should be event collector. So if I'm going to search, I still don't have that. So this one is not going to accept this HTTP event payload. So let's go back again and change that to number 4. It was number 4. It was number 4, or let me see. Event. Actually here, number 4. Now it's a success again. So let's go back. Let's search it. And here we go. Now we have that entry here. So this is how we use the curl command to help developers kind of send those logs to the HTTP event collector. Now we have been using so far the authorization header. What we can do based on the Splunk documentation, which is here, it's a very good documentation. We can use actually basic authentication. So we can provide the -u, which is the username plus the token. So we don't need to provide the password. It's just that the admin user and the same heck token. So let me show you that. So let's go back. This is the token. I'm going to delete basically Splunk. Instead of authorization, I'm just going to include Splunk as a user because I have the Splunk user. And instead of -h, I'm going to use -u. It's a success. So let's go back and search. So it should have 4 entries now instead of 3. And here we go. This is the 4th entry. In this section, we will be implementing our last and final lab, which is part of the Splunk Enterprise Certified Admin course. Now, before we deep dive into our Splunk lab setup, let me give you an idea and an overview about the different Splunk components, as well as the different data collection methods that we're going to be implementing throughout this lab. Also, in this lab, we will be simulating different use cases taken from the real world. So, if you remember from the previous slides, we've already shown you how to configure an HTTP event collector and forward those HTTP requests to the indexing tier. On the other hand, as part of the network input, I have shown you how to configure a FortiGate firewall to forward the logs via syslog to the indexing tier. Furthermore, we have shown you how to deploy and configure a universal forwarder on a Windows machine, and then deployed the Windows TA that we have downloaded from Splunk Base to monitor certain files and directories and forward the logs to the indexing tier. Similarly speaking, we have shown you as well how to deploy and configure a universal forwarder on a Linux-based machines, and then leveraging the Linux TA that we've downloaded as well from Splunk Base to assist us into monitoring certain files and directories on this Linux machine and forward the logs to the indexing tier. Lastly, as part of the scripted inputs, we have shown you how to create a custom app leveraging some pre-existing scripted inputs that would run on a scheduled interval to pretty much collect diagnostic data from OS commands and forward the output to the indexing tier. So all what we have learned in the previous slides, we will actually implement these different collection methods throughout this lab. Now, while it is okay to forward the logs from the universal forwarders to the indexing tier directly, however, in the real world, it's almost always advised to have intermediate forwarders in between. Now, the reason why a lot of customers would have these end machines, whether they are Windows machines, servers, or Linux machines, which are going to be deployed in different geographical locations. So there could be a problem that the network bandwidth is limited. So these intermediate forwarders could act as a relay. Also, maybe there are certain use cases where you're going to be forwarding data which contain sensitive information. Take the example of credit card information. So you don't want to store such sensitive information directly on the indexer. So what you want to do is you want to manipulate the data. So basically, as it transits and flows through the intermediate forwarders, maybe you would like to apply some certain data masking as it flows throughout the intermediate forwarders. So the end result is that the data, while it's going to be written into disk, it's going to be manipulated or masked. Now remember that we will configure these universal forwarders to actually perform automatic load balancing of the data. So in essence, we will instruct this universal forwarder first to forward the logs to the first intermediate forwarder and then to the second intermediate forwarder. This is very much important for data consolidation as well as for fault tolerance. Now, once we are done with this, what we're going to be doing is, instead of applying and deploying the configurations, and what I mean by that, the custom apps and add-ons directly on these universal forwarders, instead, we will be relying on the deployment server that we're going to be using it as a tool to manage all these deployments from a centralized location. This is very much true in very large environments where it's going to become really difficult to keep track of every single universal forwarder. So instead, we will be using the deployment server to facilitate this job for us. In the previous section, I have walked you through the different Splunk components as well as provided an overview about the different use cases as well as the data collection methods that we're going to be implementing throughout this lab. Now, in this section, however, instead of configuring and deploying the Splunk instances on my local machine, however, we will be switching gears and rely on AWS to actually deploy our Splunk instances in distributed architecture design. So the reason why switching to AWS is just that because in this specific lab, which is this one here, we're going to be deploying a lot of Splunk instances. So for the folks out there that you don't have enough hardware specs on your computers, I would highly suggest to go ahead and create an AWS account. So let's actually go ahead and create and launch a server instance. So I'm going to go ahead and click on Launch Instances. And then for the sake of this demo, I'm going to just name my instance as Splunk Demo. Of course, I'm going to be choosing the Ubuntu flavor, which is my Linux-based distribution. Now, if you see here, this is a free tier eligible. So let's go through that. Now, this is an instance type of T2.micro. So if we compare the instance types as well as the prices, you would see here that this is of type micro that comes with one virtual CPU and 1 GB of memory, which could handle low to moderate network performance at a price of $0.0116 per hour. So you can actually deploy your whole Splunk environment and maybe you keep it running for 1 day or 2 days as soon as you're done with your lab, and then you can just terminate all your Splunk instances. So let's go ahead and choose this one. Now, bear in mind that I'm choosing this one specifically for the universal forwarders and for the intermediate forwarders. Because if we go back to our hardware reference, which is in Splunk documentation, this one, so you'd see that the minimum specs for a universal forwarder is 1.5 gigahertz of CPU, and a RAM of 512 MB and a free disk space of 5 GB, which specifically for this lab setup would be more than enough. So let's go back to our launching instance. So in here, what I'm going to do, I'm going to set up a public key authentication for SSH. So by creating this new key pair, it's going to enable me to log in to this instance via SSH. So let's go ahead and create a new key pair. So I'm going to name it as well Splunk Demo. Now I'm going to create this one, and as soon as I create this one, I'm going to download the private key. So let's go further with the network settings. I'm going to leave it as it is. I'm going to create a new security group. Now here, this will allow SSH traffic from anywhere. Of course, we don't want to do that because that means that we're going to be exposing our instance to the whole internet. And we don't want to do that. So let's keep it here as it is. And then we will go ahead and make the change in the next section by creating a new security group. So let's leave the configuration for the storage to 8 GB, which is more than enough. So let's launch the instance. Now this will take a bit of time. As soon as it's done, then we will go ahead and open it. So we have just created this Splunk demo. And as you can see, it's still in the build process. So let's click on it for a moment and let's go through the basics of its network configuration. Now here, this is the public IP where AWS has assigned it to this instance. So using this one is going to enable me to SSH to this instance. And this is actually the private IP of this instance. And we will cover that more in depth later on. Now, what is very much important for me is under security. So under the security, we see that there are the inbound rules and the outbound rules. And of course, by default for the outbound rules, you mean that all the traffic leaving, egressing your instance is going to the internet, and we're allowing that pretty much. However, for the inbound rules, we will need to make sure that we restrict access to this instance. So what we need to do is we need to go to security groups in here, and let's go ahead and create a new security group. So I'm going to name this as Splunk Demo Instance Group. I'm just going to provide a meaningful kind of description. So I'm just going to put SSH, HTTP, HTTPS, and maybe Splunk port. Now, I'm going to add, in the inbound rules, I'm going to add a new role. So I would like to restrict access for SSH, not to everyone from the internet, but only to me. So what I'm going to do, I'm going to go ahead and I want to see what is the public IP of my ISP provider. So what is my IP address? So this is actually the IP address. So let me copy this one. Let's go back to our instance. Let me just provide the CIDR block, which is a 32. Now, let's add a new role. And this one specifically to provide access for the web GUI of the Splunk instance. And if we go back to here, you can see, according to this documentation, you will need to provide access to port 8000. So you're able to access Splunk Web. So let's go back in here and also provide my public IP. In your case, you need to provide your public ISP IP address. So let's add another rule. I'm going to just add 443, just in case we will need it later on. And then also I'm going to allow also port 80, 32, and I think we are done. Maybe we will need to add other ports, but for now, let's keep it this way. So let me just create this security group. So now that we have just created the security group, let's go ahead and click on the instance that we've just created. Then we go to action, and then we add the new security group. So let's go ahead and add this new security group, which is the Splunk Demo Instance Group. So let's click on that one. Let's add the security group. And this is the one. Let's save it. Once we are done, we can go back to security. And we can see that we have added these new ones. Now take a look in here. Of course, we don't want to have this one. So what we need to do, we need to go back again and then delete this one. So let's go to action. Let's go to security, change security group, and then we will need to remove this one because this one was added during the configuration wizard. So let's save this one. So now that we have already set up the security group and we made sure that the open ports are only restricted to be accessed from my public ISP provider IP address, now let's go ahead and connect to this instance. So what I'm going to be doing, if you remember from previous section, what we've just discussed, the creation of the public private key. So basically I've downloaded the private key. What I'm going to do, I'm just going to copy the content of this private key. So I'm just going to copy this one, copy, and then I'm going to go back to my Linux machine in here. I'm going to do sudo nano. I'm going to name it maybe private_key.pm format. Paste it. Control X. Save it. Now I have the private key. I've just copied it from here. What I'm going to do, I'm going to change the file permissions of this private_key.pm format. So sudo change mode to 400 and then private_key, which is this one. So let's go ahead and copy this one here. So we go back, we paste it. However, if you remember, we named our private key as private_key.pm. And let's put sudo at the beginning. Now that we have successfully connected to our AWS instance that we have just launched earlier, now you need to repeat the same steps again into configuring and deploying all the other Splunk instances which are part of our lab. So spend some time to go ahead and repeat the same steps and create all of this in preparation for our lab deployment. In this section, I will walk you through how to deploy the different Splunk components in a distributed architecture design. So let me bring my notes to the front, and then let's discuss that briefly. So as previously mentioned throughout my last two sessions, I have given an overview about our lab setup. So basically this one, and we have identified the different components as well, the different methods in terms of data collection and what we're going to be implementing. Then in the second section, I have shown you that the best way to actually deploy this lab is to create an AWS account. And then I have shown you as well how to launch a server instance and then taking care of all the basic configuration and accessing and connecting to that instance. Now, for the folks out there, again, if you feel that AWS is not the good choice or the right choice for you, you can always also rely on VMware Workstation, where you're going to be deploying it on your local machine. And of course, you can deploy all the different components of Splunk. Obviously, if you're going to have enough hardware specs, then you could go with this method of deployment. So the choice is yours. So let's go back to our notes. Now, in this section, however, what we're going to be doing is, so let's go through these steps. Deploy the indexes and configure the monitoring console. So first things first, in such an environment, what we need to first focus on is to actually deploy the two indexers. So what I'm going to do, I'm going to first deploy indexer 1 and indexer 2. And then I will set up the monitoring console. I will deploy it on a separate instance. And then once we are done, I will then deploy the search head and adding it to the distributed environment. So we would want that all our Splunk nodes, except for the indexers, to have all of them forwarding their internal logs to the indexers instead of indexing them locally. So this reduces disk space usage, and it makes as well the internal logs for all the Splunk nodes searchable without having to necessarily logging in on every single Splunk component. So basically, we would want to instruct the heavy forwarder, the intermediate forwarder 1 and 2, as well as the different Splunk auxiliary components, and I mean by that deployment server, monitoring console, as well as the search head, to forward their internal logs to either one of these. So for the sake of this lab, I'm going to be choosing indexer 2 to parse and index all the different internal logs. Now, once we are done with this, I'm going to be configuring the monitoring console in a distributed mode. So let's go back to our notes in here. Now, follow my best practices where I walk you through configuring the ulimit and disabling the THP in previous sections. So for the sake of this lab, I'm not going to configure the ulimit or disabling the transparent huge pages because I've already provided a demo on how to do this. So I would encourage you to go ahead and follow the previous sections where I have explained that and also provided a demo on how to do it. Now, once we are done with this, I'm going to do post-installation checklist. And then we will deploy the intermediate forwarders and deploy the universal forwarders, but we're not going to do any configuration, just deployment. And then we will go ahead with the deployment server and we will configure it. And then we will configure those intermediate forwarders as well as the universal forwarders to be acting as deployment clients to our deployment server here. Once we make sure that those universal forwarders and intermediate forwarders and the heavy forwarder is showing actually under the deployment server, then it comes the interesting part where we're going to go ahead and configure our custom apps and add-ons that we will actually deploy through the server class to all of these different universal forwarders as well as the intermediate forwarders. Lastly, we will configure the HEC on this heavy forwarder as well as we will configure a firewall to forward the logs via syslog. In this case, is going to be a FortiGate firewall to the heavy forwarder. So once we are done with this, we're going to end our lab with data onboarding. So basically, we will prepare a test environment to test our sample data. And of course, we'll make sure to get the metadata fields correctly from the beginning. And obviously, we will actually use the data previewer and use the props.conf, to get this data parsed correctly. So basically, we will make sure to get the timestamp correctly, identifying the event boundaries, field extractions, and obviously, we will walk you through all of these different controls that's going to help us into parsing our data. So let's go ahead and jump to our lab setup. So in this section, we will go ahead and deploy the different Splunk instances. So I've already configured indexer 2, indexer 1, as well as the monitoring console and the deployment server. And I left the search head intentionally for you so we can actually go ahead and do that together. Now, feel free to follow the same steps that we're going to be doing in deploying the search head and apply the same steps to deploy indexer 2, indexer 1, and the monitoring console, deployment server, as well as the heavy forwarder. Because in essence, we're going to be using the same Splunk package across all of these different components. While for the universal forwarders and the intermediate forwarders acting as a universal forwarder, then we will use a different Splunk package, which is only for the universal forwarder. So let's go ahead and actually do that. So what I'm going to do, I'm just going to launch instances. I'm going to create the search head. And I'm going to use the Ubuntu flavor. Now, previously, we mentioned that for the universal forwarders, one virtual CPU and 1 GB of memory would be enough for this lab. However, if we go for the system requirements for the search head or for the indexers, they would require 16 physical CPU cores or 32 virtual CPUs and 12 GB of RAM. And you see, this is the minimum specs. Of course, for our lab, I've already tested that. It would be more than enough to go maybe with, I would say, the medium instance. So 2 virtual CPUs and 4 GB of memory would be enough. Now, to compare the instance types in terms of pricing, you can see that the medium would cost you $0.046 per hour. So what you can do, again, as previously mentioned, you can just create and deploy this lab for a couple of days. And once you're done, you can just terminate that. So let's go back and select the instance type. And now we have assigned the 2 virtual CPUs and 4 GB of memory to our search head. Now I'm going to be selecting my key, which is going to be this one. So network settings, I'm going to leave it as it is. Actually, in my lab environment, I will be choosing the default. So this is the one. And now 8 GB of storage would not be enough. I might increase that to 15. So let's keep it that way. Now, let's go ahead and actually launch the instance. So now that our search head is up and running, what we need to do is we need to make sure that we are able to actually access the search head from our end. So to do that, we need to assign the proper security group. So let's go ahead to this instance. So let's click on this one and let's go to action, and under security, change security group. Now I'm gonna provide the security group that we have created earlier. So that would be the Splunk demo instance group. So I'm gonna add this security group and I'm gonna save it. Now, once we're done, let's go back to the search head. And under security tab, we can see what ports are allowed to this new search head instance. So I've allowed 8000, which is the default web GUI port for Splunk Web, 443.22 SSH, and I'm only allowing it from my IP, which is the IP address of the ISP provider. So now that we're done, so let's go ahead and connect to this instance. So let's click on connect. I'm just going to copy this one. By the way, feel free to change this one to the actual public IP address of this instance. So you can still do that. So I'm just going to paste it in here. I'm going to include sudo and the proper private key. Private.pm. Yes. And you can see now that we have successfully logged in via SSH to this server. So let's go back to the server. Now this is the public IP address that I was mentioning. Now what we need to do is, let's go ahead and change the name of this instance. So sudo vi, or actually nano, etc host name. I'm just gonna maybe put search head, just like that. And then we need actually to do a reboot for this to take effect, but you can leave it as it is, but we can still do that. So now I've changed the host name, and now what we need to do, let's create the Splunk user. So sudo add user Splunk, provide a password, retype the password, accept, yes. Now that we have the Splunk user, we need to go ahead and go under OPT. Now let's go to Splunk. Let's log in. Just gonna log in. And then I'm just gonna copy the wget command so we can install and download actually the Splunk Enterprise. So let's go to free trials and downloads. So Splunk Enterprise. And then I will choose Linux. And I'm going to choose the target Z file. So I'm going to click on this one. And under download via the wget, I don't need this one. I'm just going to copy the wget command. Copy. Let's go back in here. Paste it. Don't forget to add the sudo. So now I'm downloading the Splunk Enterprise package. I have it in here. So sudo, let's untar this file, sudo tar -xzvf Splunk. So I'm untarring it. So once we are done, we need to change the ownership of the Splunk directory. So you see, we need to change those. So what we need to do is sudo chon -r for recursive, Splunk, and then Splunk. Now, if we see, now we have changed the ownership. Now, bear in mind that as previously mentioned, you need to go ahead and enable the and configure basically the ulimit, as well as disabling the transparent huge pages. These are best practices provided by Splunk. Now, for the sake of this lab, I'm not going to do those, but please feel free to go ahead and do that. And you can follow my previous sections where I have provided a thorough demo on how to configure the ulimit, as well as disabling transparent huge pages. So now that we are done with Splunk, feel free to remove this one. So sudo remove Splunk-9. So now we are left only with the Splunk directory. So cd opt Splunk. Now what I'm going to do, sudo zoo Splunk. So let's go ahead and actually start Splunk. So bin Splunk start. Hit Q and then Y, accept the license agreement, and then I'm going to create a Splunk user and a password, and I'm going to confirm the password. So once we are done and the Splunk instance is up and running, then we can confirm that. So let's wait. So now Splunk is up and running. What we can do, status, and you can see Splunk daemon is running. So now that we have successfully connected via SSH and we have also deployed the Splunk on this search head instance, so let's go ahead and connect via the web. So let me just copy this IP address. So this is the public IP address. I'm just gonna paste it in here, and I'm gonna include the port 8000. So I'm just gonna include Splunk, the username. So now let's go to settings and actually validate few settings under the server side. So if we go to general settings, this is the management port. This is a Splunk server name. You can actually also change it in here. So you can do search head like this. Run Splunk Web, yes. Enable SSL HTTPS on Splunk Web, yes. Let's do that. Web port is 8000. So that should be okay. I'm gonna also include here search head. So let's save that. And what we can do now, it requires a restart. So let's just go ahead and restart Splunk. Let's wait for a minute. Of course, now what we need to do, we need to include the HTTPS in here. And your connection is not private because we're using a self-signed certificate on the Splunk side. So now just include the username and the password again. And now we're able to log in to the Splunk web again. So basically, let's go back to our lab. So basically, we have deployed the server on AWS, as well as we have successfully deployed the search head on this server. So now we have the Splunk search head up and running. What I would encourage you guys from now on is to go ahead and repeat the same steps to configure the indexer 2, indexer 1, the deployment server in here, as well as the monitoring console. So now, once you have provisioned all the servers in here, and I'm talking about the search head, indexer 2, indexer 1, the monitoring console, the deployment server, and the heavy forwarder, as well as deployed the Splunk on these different hosts, as I've done in here. Now, what you need to do is you need to configure all of these instances to forward the logs, the internal logs, to indexer 2. So basically, from the heavy forwarder, from the search head, from the monitoring console, as well as from the deployment server, forward all their internal logs to indexer 2. So let's do that together. Now, what I would suggest is to have the public IP column here and the private IP addresses here, and we're going to be using actually the private IP addresses. So what I've done, I have just wrote down, so I've written down all of the public IP addresses and the internal IP addresses of their corresponding, AWS instances. So what we want to do now, we need to go ahead and log in to every single Splunk instance here and configure it to forward the logs, the internal logs to indexer 2, which is this one. So let's go ahead and start with the search head. So I'm going to go ahead and copy the IP address, the public IP address of my search head. So this is the one. Then I'm going to go to my CLI. And then I'm going to delete everything in here. I'm just going to paste it, hit enter. So I have logged to my search head, cd to opt, cd to Splunk, etc apps. So under the apps directory, I'm going to create a new app. So let's go ahead and actually create this directory. So sudo mkdir, and then forwarding to indexer 2. You can name it the way you like it. And then under that, so cd to forwarding, I'm going to create another directory, which is called local. And then I'm going to also create the metadata. So metadata. So first, I'm going to start with the local. So cd to local. And here, I'm going to create the outputs.conf. So sudo nano outputs.conf. And in here, I'm going to copy the configuration, which is this one. So copy, paste. So I'm going to put the the server IP for my indexer 2. So if I go back to my notes, I'm going to copy the internal IP address. So let me paste it, save it, and then go to meta. And then in here, I'm going to copy basically the configuration. So bear with me a moment. So I'm just going to copy this one, copy, and then I'm going to create sudo nano local.meta. Hit enter, paste it, Control X, Y. So now let's go out from here for a second. So if you notice, I've created this app now for forwarding. So what I'm going to do, I'm going to change the ownership. So sudo chon -r Splunk. And then I'm going to give that app name, the path. So now I have that under Splunk. So what I'm going to do, cd, and then I'm going to do sudo zu Splunk. And I'm going to restart my Splunk instance here. So bin Splunk restart. So let's wait for the search head to restart. And in the meantime, what we're going to go, I'm going to go to indexer 2, which is this one. Let me just copy this IP and go HTTP and access that indexer 2. So let's wait for a second. So it seems like it's not running. So what I want to do, I'm going to log in to the indexer 2, which is here. And I've done Splunk status, and I can see Splunk D is not running. So what we're going to do on this indexer 2, I'm going to do start. So let's start it. Let's wait. And once the indexer 2 is up and running, then hopefully we will be able to get to the Splunk web. So let's do a reload. And here we go. So now let's log in to the indexer. So I've already restarted the search head. So for the configuration to take effect. Now I'm going to go to the search and reporting. Just to make sure that the configuration that we have done is correctly, that we have actually created the app, which is this app. Let me show you. So we have created basically this app and the outputs.conf to forward the internal logs from the search head to the indexer 2. So let's go to the indexer. So we're going to do index equal to underscore internal. And let's do pipe stats count by host. So still we don't see anything. Last 15 minutes. Of course, why we're not seeing anything? So folks, that is because we've only configured the search head to forward the logs to the indexer 2. But remember, we never configured the indexer 2 on listening mode. So what we need to do actually, we need to go to the indexer 2, which is this one here. And what we need to do is, we need to configure this indexer 2 for listening mode. So let's go cd opt Splunk etc apps. And then here I'm gonna do the same. So make directory. I'm gonna call it listen app underscore listen. Inputs. And then I'm gonna do local, and I'm gonna do metadata. So let's go to the app underscore listen local, and in here I'm gonna create nano inputs.conf. So in here I'm just gonna paste this configuration. So I'm instructing this indexer to listen on incoming traffic on port 9997. So let me just save that. And then I'm gonna go and create the metadata local.meta. So cd to metadata and then nano local.meta. I'm gonna paste the same configuration in here as well. So what I'm gonna do is under meta, this one. So copy this one and then paste it in here, Control X. So let's make sure that the ownership of this app is Splunk. Yes, it is. And you can see this is the one. Now, once we are done with this one, we need to restart the Splunk instance in here. So I'm going to do bin Splunk restart. So let's wait for a while until this instance is restarting, and then we will verify if this indexer is actually listening on 9997. So let's wait. So to verify this, let's do ss -an, and we want to grep for 9997. And you can see that this indexer now is listening on 9997. Now let's log back again to our indexer, which is indexer number 2. And now let's search for the last 15 minutes again. So now, as you can see, now we are actually receiving the internal logs from the search head on this indexer. So this is what we have done. So basically, we have instructed the search head through the outputs.conf to forward the internal logs to the indexer 2. Also, we have seen that first we forgot to enable the 9997 on listening mode. So this is what we have done. So now what I would encourage you to do is copy the same configuration that we have done in here to indexer 1. And also the same for the search head to copy the outputs.conf to the monitoring console, to deployment server, and also to the heavy forwarder. So what I'm gonna do, basically, let's go and do that. So from the search head, I'm gonna SCP that app to basically monitoring console, to the deployment server, to the heavy forwarder, so we can receive all the logs, all the internal logs on indexer 2. So let's do that together. So let's go ahead and copy the app that we have just created under the search head, which is this one. Let me show you. The forwarding to indexer 2, so the internal logs. We need to copy this app to all the other Splunk instances. And what I mean by that, the heavy forwarder, the monitoring console, the deployment server. And to do that, all what we need to do. So what we need to do is we need to go ahead and use this scp command. So let's first paste the IP address of our deployment server. So I'm gonna copy this IP first. So we're gonna copy it to the deployment server, paste it under the temp directory. Now we are facing this issue, permission denied. So how to fix this issue? So what we need to do is we need to go back to our instance. So let's go to the instances. So let's go to the deployment server in here. Let's click on connect. Let's copy this one and let's go back to our terminal, paste it. I'm going to change the private key, private.pm, include sudo. So I'm in the deployment server now. So what we need to do basically, we need to copy basically this one. So let me copy it, paste it in here. Then we need to find the value, which is password authentication, and we need to change this to yes. So let's save that. And then let's do a systemctl restart of the SSH server. Copy, paste, all is good. So now let's go back to our search head. So cd opt Splunk etc apps. And now I'm gonna just copy the IP address of this instance, which is the private one, which ends with 218. There you go. And I'm gonna just hit enter. And I've copied that app to the deployment server. So let's go back to the deployment server now. cd opt, or actually cd temp. And this is actually the directory. So let's do sudo copy forward to opt Splunk etc apps. So we need to do and include a -r for recursive. So now cd opt Splunk etc apps. Let's do lslh, and this is the one. Let's change the ownership. So sudo chon -r Splunk, and then forward. Now that we are done, what we need to do a restart. So zoo Splunk, and then do bin Splunk restart. So now we are restarting the deployment server. Let's wait for it to finish. And then we will go back to our indexer to see if now the deployment server is sending the internal logs to the indexer too. So let's wait for a moment. So let's go back to our indexer. Let's do search. And here you go. Now we can see the deployment server as well. So once you have copied the app that we've created on the search head to forward the internal logs to the indexer to, and I mean by that to the heavy forwarder, to the monitoring console, to the deployment server, then you should see something similar to this. So I am logged on the Splunk indexer 2, and you can see that now I'm receiving all the logs the internal logs from all these Splunk instances. So in this section, I'm going to go ahead and deploy the intermediate forwarders as well as deploying the universal forwarders. So basically, if we go back to the diagram in here, I'm going to deploy these two intermediate forwarders and these universal forwarders, as well as I'm going to deploy the universal forwarder on my Windows machine. At the same time, I'm going to deploy on all of these universal forwarders and intermediate forwarders the deployment client app, so I get them to phone home back to the deployment server. And I'm going to use this deployment server as a centralized tool to configure all of these instances by deploying to them the apps, the add-ons, and the custom apps that I'm going to be creating. So let's jump ahead to my universal forwarders here. For the sake of this lab, I'm going to configure one intermediate forwarder, and you can actually follow the same steps to configure the other intermediate forwarder. So let's click on this one. Let's go ahead and connect. I'm going to copy, and then I'm going to go ahead, paste it. Let me just enlarge it. Then I'm going to just change the private key. So private.pem. And of course, sudo. So now I'm logged into the intermediate forwarder 1. So let's go ahead and log into Splunk so I can get to download the universal forwarder package in here. So let's go to Splunk. Let's log in again and provide username, password, and then we can go to products, free trials and downloads. We scroll down to universal forwarder, get my free download. So on Linux, I'm going to download the 64-bit. So this one, so it's the target file. So let's download that one. Just gonna go to the command line and I'm just gonna copy it from here. So copy. Let's go back to the CLI. Nope, not this one, this one. So let's go cd opt. So now I'm just gonna paste it, do sudo, hit enter, download it. There you go. So sudo, let's untar it, tar -xz vf Splunk. Let's untar it. So once we are done, let's check it. We need to change the ownership. So Chon -r Splunk. I've already created the Splunk user. So for the folks you don't know how to do it, so sudo add user Splunk. So if I do it, it shows that I've already added it. So now cd to Splunk, and now sudo -u Splunk bin Splunk start, hit Q, yes, provide the username. You need to create a username and a password. There you go. So now it is up and running. We can verify that. Status. So Splunk D is running. Now at the same time, what I want to do, I want this universal forwarder, which is the intermediate forwarder in here, to actually phone home back to my, so let's go back to our diagram. It's loading. Yeah, so I want this universal intermediate forwarder here to phone home back to the deployment server. So to do that, I've already prepared an app. So let's go to that app and let's copy paste the configurations. So let's go to that one. So the app is Demo Lab Deployment Client. So what I'm going to do, I'm just going to rename, copy, I'm going to go to my CLI. So you can either SCP that or you just can copy and paste it. The choice is yours. So CD to etc apps. So here I'm going to create sudo make directory, and then I'm going to paste it. And then I'm going to do local, and I'm going to do metadata. So I've already created this app. Now we need to copy paste all the content. So CD to demo lslh, we have local and metadata. So CD local, and in here I'm going to go back to my app, which is this one. Under local, I'm just going to edit it. And I'm just going to copy this. And I'm going to go to my CLI, sudo nano. And then I'm going to type deployment client.conf. So let's hit enter. Let's paste it. Of course, the target URI here, you need to provide the IP address of your deployment server. So let's go back to our deployment server in here under instances, and let's take the private IP address of our deployment server. So this would be the IP address. So let me just copy that. Let's go back to here. Let's paste it. Control X. Yes. It's going to phone home every 60 seconds. So deployment client.conf is created. One directory up. Let's go to the metadata. And then in here, I'm going to create the second configuration, which is the local.meta. So let's go back to our app, this one, and let's open this one and edit it with Notepad++. By the way, I'm going to provide all these apps, into the resources. So sudo nano local.meta. So paste the configuration, Control X, save it. Now we have created the demo lab deployment client, which is referring to the phoning home interval of 1 minute. Now what you can do, you can copy this app basically to all of your other universal folders and intermediate folders that you're going to have. So let's first change the ownership of this directory. So sudo chon -r Splunk, then demo. Now let's verify that it has changed. Now we're gonna restart our intermediate folder in here, which is basically a universal folder. So let's do sudo -u Splunk, and then bin Splunk restart. Let's wait for this to restart. So once it's restarted, we can go back to our, so let's go to our lab first and discuss that briefly. So now I have configured the intermediate folder, number 1, this one, and also I've created, as I've shown you, the app. So it's going to enable this intermediate folder 1 to phone home back to the deployment server. So let's give it a moment, and now let's go to the deployment server and access it via the web and see if that intermediate folder is actually showing under the deployment server. So let's go to our instances and let's copy the public IP address so we can access that remotely. So the deployment server is here. Let's copy that. Control C. Now 8,000. Let's do HTTPS. Yes. Splunk. And the password. So now I have logged into my deployment server. So let's go to settings, forwarder management. So now, as you can see, now I can see the intermediate forwarder showing under the forwarder management. So basically, we were able to instruct this intermediate forwarder to phone home back to the deployment server. And as you can see, it is showing under here. This is the client. Now, what you need to do, you need to repeat the same steps exactly to deploy the universal forwarder package into your all other instances. So basically, if we go back in here, you need to deploy it on your second intermediate forwarder, on your universal forwarder here, as well as here. And then also what you need to do, you need to go ahead and copy this demo lab deployment client to all of your universal forwarders and the intermediate forwarder, except for the forwarder on the Windows machine, which I'm going to be doing it right now. So for the sake of this lab, go ahead, pause for a moment, finish the other universal forwarders and intermediate forwarder too, and then resume that we can go ahead and deploy now the universal folder on my Windows machine. So now I have all my universal folders as well as the intermediate folders showing in here. And I mean by that, if we go to the diagram again, we have those two as well as those three. Actually, I have universal folder 1, universal folder 2, and I have a universal folder 3 as well as another universal folder, which is the Windows. So what I'm going to do, I'm just going to delete this and I'm going to go back to my Windows machine. So let's go first to download the universal folder for Windows. So let's go to universal folder. Then Windows, I'm going to choose this one. Now let's command line. Actually, I'm downloading it here. There you go. Now, folks, make sure that you follow the same steps that I've shown you in creating and deploying the app for the intermediate folder 1. Just replicate the same steps across the others. So let's go ahead for the universal folder on my Windows machine. Let's run it. Now here, checks the box to accept the license agreement. On premises. Next, I'm gonna provide a username. Actually, we can generate a random password. That should be okay. Next. Now here is showing me, do you have a deployment server? Yes, I have a deployment server. So what I'm going to do, instead of providing the private IP of my deployment server, I need to provide the public IP because this universal forwarder is on my local machine, whether these instances are on the cloud, on AWS. So what I need to do is I need to go to the deployment server and copy this IP. So let's go back to the configuration. Paste it, 8089. Now, bear in mind, if you restart or reboot this deployment server instance, then this IP is going to change. So make sure that you don't restart or reboot, the deployment server instance. Now, of course, 8089, next. receiving index, don't do that, leave it as it is. Let's go for next, install. Now, let's wait for this to install. Now, we need to know if my universal forwarder on my Windows machine can actually reach the deployment server. So let's click on my deployment server and let's check the security group and see if I'm allowing access from external or from the internet to my deployment server. So I can see in here the inbound, I'm allowing 8089 from anywhere on the internet, which should be okay. So let's go back to our universal forwarder. Let's do finish. Let's go back to the forwarder management. Let's do a refresh. And now, in fact, I can see that from my local machine here, I'm able to see it under the forwarder management under the deployment server. So now that we are ready, we have now successfully done this part and also this part. And we've also deployed the app so we can control the behavior of all these universal forwarders and intermediate forwarders from one centralized location, which is the deployment server. Now, if we go back actually to our deployment server and we expand, we can see that there are no apps assigned to these intermediate forwarders as well as the universal forwarders. So now we are able to see the intermediate forwarders, the universal forwarders, as well as the universal forwarder, which is deployed on my Windows machine under the forwarder management inside my deployment server. So now what I'm going to do, I'm going to use WinSCP to actually copy these apps that I've already prepared, which I'm going to be sharing as well with you using WinSCP, and I'm going to copy those from my local machine to this deployment server. So let's go ahead and do that. So I'm just going to go to my WinSCP, and this is my public IP address of my deployment server, which is deployed on the AWS. Just going to log in. It's going to take a moment. So I've logged in. So what I'm going to do, I'm going to go under Splunk /etc deployment apps. This is where the apps should live. So they should show up here. Let me just show you that here. So let's go ahead and do that. I'm going to go to my directory. I'm just going to copy those apps that I've created to here. So it's going to take a while. And now let's go ahead to my deployment server and actually log in via SSH. So let's do that. Clear. And then I'm just going to paste the IP address of my deployment server. Let's log in. Here we go. So we logged in. Let's go to cd opt Splunk /etc deployment apps. Let's do ls-lh. And as you can see now, I have all my apps that I've copied using the WinSCP in here. So I can see them in here. So basically make sure that the ownership of those apps are Splunk. So let's go to the forwarder management via the web and let's do a refresh. So now I'm able actually to see the apps that I've deployed. Now you need to use a naming convention or a way that you can recognize the apps that you're going to be deploying. This is very much true in very large environments where this list could grow rapidly as well as the clients. So what we're going to do is we're going to link an app to a deployment client. And the way to do that is through the server class. So now we have the apps listed in here. We have our clients, the deployment clients in here, which are a bunch of universal forwarders, intermediate forwarders. So we're going to create a server class, as previously mentioned in my slides, to link an app to a deployment client. So let's go to our diagram. So let's discuss that briefly. What I'm going to do first, I'm going to deploy an app to these intermediate forwarders so they can forward the logs to indexer 1. So let's do that together. So first, let's go and examine this. Now, for indexer 1, the internal IP address ends with 126. Actually, with 125. This is the private IP address. So let's go to our CLI and check that. So the app that I'm going to be using is Demo Lab IF Outputs Base. So let's cd to demo IF, and then let's go to local, and let's do sudo nano outputs.conf. And as you can see, this is the destination IP address of our indexer 1, which we verified. So now, actually, we need to change this to indexer 1. So it's always good to verify if you've configured your configuration correctly, your parameters. So now I've saved it. And let's make sure that it is Splunk. Good. So now I'm going to go back to my forwarder management, and I'm going to go ahead and create a server class. So let's go ahead and create one. So I'm going to name it intermediate forwarder base outputs to indexer 1. Now we're going to add the app. So I'm going to be using the Demo Lab IF outputs base. Let's save that. So now I'm going to add the clients to this server class. So let's add the clients from here. So I'm going to include intermediate forwarder 1 and intermediate forwarder 2. So let's do that. So this is intermediate forwarder 1 and this is intermediate forwarder 2. So what I'm going to do, IF and then a star, which is going to match against this one and this one. So let's do a preview. And in fact, we've chose both. And then what I'm going to do, I'm just going to save that. So now we can see that this app, which is the Demo Lab IF output space, has been deployed to IF1 and IF2. Now, to confirm that we are actually now receiving the logs from intermediate forwarder 1 and intermediate forwarder 2 on the indexer 1 here. So this way, let me show you. So let's go to our search head and actually formulate a query for that. So let's go to our search head here and let's go for index internal stats count by host. Let's do for the last maybe 15 minutes. Let's search. And as you can see now, we are receiving also the logs from IF1 and IF2. So now that we have configured those two intermediate forwarders to forward the logs to indexer 1 from here, so now what we need to do, we need also to create another server class to instruct those two intermediate forwarders to listen for incoming traffic from these universal forwarders. So first, let's go ahead and actually create another server class. So let's go in here and let's create a new server class. And I'm going to call it if underscore base underscore inputs. That's it pretty much. So let's save it. And now let's add the app, which should be demo lab input space. So basically in this app, we have the configuration to enable the listen on 9997. So let's save that. Let's add the clients, which would be IF1 and IF2. So paste it, put a star, which is a wildcard, preview. So IF1 and IF2, let's save that. Let's edit. And let's do also trigger a restart on these two intermediate forwarders. So now what I'm going to do, let's go back to our lab diagram. I'm going to instruct the universal forwarders, which are deployed on my Linux machines in here, to forward the logs to load balance the data to intermediate forwarder 1 and intermediate forwarder 2, and the same for this one to intermediate forwarder 1 and intermediate forwarder 2. So what we need to do, we need to create another server class. Now, the reason why I'm excluding the universal forwarder, which is deployed on my Windows machine, because for this one, which is installed on my local machine, I need to provide the destination IP, which is the public IP address of the intermediate forwarder 1 and intermediate forwarder 2. So we will need to create another app for that. So first, let's focus on those universal forwarders which are deployed on my Linux machine. So let's go back to the forwarder management. Let's create another server class. And I'm going to call this server class UF underscore base underscore outputs to IF. So let's save that. Let's add the app, which is demo lab UF output space. Let's save that. Let's add the clients. And this is a wildcard, so I'm going to put a UF star. Let's preview. So I'm selecting UF2 and UF3, but I didn't assign the proper host name to this one. So I'm just going to copy it and I put a comma. I'm going to paste it in here. Let's do a preview. So I'm selecting also this one. So let's save that. So basically now I'm going to do an edit to trigger also a restart on these three universal forwarders. So now I have deployed an app to configure those three universal forwarders to forward the logs to the intermediate forwarders. So basically, those to load balance the data to the intermediate forwarders like this. So let's go back to our search head and make sure that this is working. So this is the search head. So let's go back and verify that our new universal forwarders are actually forwarding the logs as well through the intermediate forwarders to our indexers, which is indexer 1 in this case. So as you can see now, we're actually receiving logs from UF3 and from UF1, and we should see as well maybe UF2 soon. So let me just do the last 15 minutes. So now we're actually able to see as well UF2, UF3, as well as our universal forwarder 1. So let's go back to our diagram in here. So we have configured as well the universal forwarders to forward the logs, load balance the logs to intermediate forwarder 1 and intermediate forwarder 2, and these two as well to forward the logs to indexer 1. And all what we have done is through the deployment server from a centralized location. And now what we're going to do, we're going to go ahead and create a new app solely for the universal forwarder deployed on my Windows machine. So to do that, what I'm going to do, I'm going to go to my deployment server and connect via SSH. So let's do that together. So let me just copy the IP address of my deployment server. And let's go back to my CLI. I'm going to paste the IP address. So what I'm going to do, I'm just going to create a new app and I'm going to rename it. So I'm going to copy the content of this one to a new directory. So let's just copy that. I'm going to do sudo copy -r demo lab ufs outputs base. And I'm going to rename the new one as _Windows. So this is only for the Windows machine. So let's save that. Now I have created a new app in here. So what I'm going to do, I'm going to cd to that one, uf _Windows. I'm going to do sudo nano local and then outputs.conf. And in here, instead of my private IP addresses of these two intermediate forwarders, I'm going to provide the public IP addresses, because you remember my Windows machine is locally where I have deployed the universal forwarder. So let's go to the instances. And I'm going to copy the public IP address of my intermediate forwarder 1 and 2. So this is the first one. I'm going to paste it in here. Let's go to the second one, which is this one. Copy it. And then going back in here, I'm going to remove the private IP of the same intermediate forwarder. Just going to paste it like this. So I'm going to save my configuration, cd, and then I'm going to do ls/lh, making sure that it has the Splunk ownership. It does not, so we need to do that and change it. Sudo chon -r for recursive Splunk, and then demo uf _Windows. So now I have my Windows app up and ready. So let's go back to the deployment server. So let's go to the forwarder management. Let's go to the apps, and the app here we have it. So let's go ahead and create a new server class solely for my universal forwarder, which is deployed to my local machine. So let's name our new server class as uf _base outputs _to if, and I'm going to call it Windows. So I know what is the server class used for, or the purpose of it. So let's add an app, which is going to be this one. Let's save it. Now let's add only my Windows universal forwarder, which is this one. So Control-C, Control-V, preview. Let's save it. Now let's edit and also enable the restart of the Splunk daemon on my universal forwarder deployed to my Windows machine. Let's wait, and then we can verify if we're actually receiving as well the logs from my Windows machine where my universal forwarder is deployed to. So I think I'm not going to receive any logs from my universal folder deployed on my local machine, because I need to check whether I have allowed the inbound traffic to this intermediate folder from the outside on 9997. So let's go ahead and click on the first intermediate folder. Let's go under security and let's check if I allowed this. In fact, I don't see anything which is allowed, basically. So what I need to do, I need to go ahead to security groups and create a new security group. So I'm gonna call it outside 9997 Windows. So Control C, Control V. I'm gonna add an inbound rule where I'm allowing 9997. Let's do it from everywhere. It's fine for now. So let's create this security group. Now let's go to my instances in here. Then I need to go to my intermediate folder 1 under actions, security, and I'm gonna add the new security group. So this is the one outside 9997 Windows. Add it, save it. Let's go to my second intermediate folder, which is this one. And I'm also going to add the new security group. So let's add that one here, add the security group, save it. So now let's go back to the folder management. And for that server class, specifically for the Windows, I need to trigger another restart. So let's save that. So let's verify this now. So now we're actually able to see the logs coming from our universal folder deployed on my Windows machine locally. So let's go to our lab diagram. Now we have successfully configured this as well. So now we have successfully deployed our custom apps from the deployment server to our intermediate folders, as well as our universal folders on our Linux machines, as well as on my Windows machine. So now what we need to do, we need to go ahead and start with the different use cases, as well as building our indexes under indexer 1 and indexer 2. So now that we have successfully deployed our Splunk components in a distributed environment, and we have verified that by going to the search head and run this SPL query, and we can see that we're actually receiving the logs from all the different Splunk components, which are the intermediate folders, the universal folders, and all the other auxiliary Splunk components. So now we go back to our diagram, and before we go through discussing our different Splunk use cases in terms of data collection method, what we need to do, we need to understand what kind of data we would like to ingest on the indexer 1 and indexer 2, so we can go and create the respective indexes. So for instance, in here on my Windows machine, I would like to monitor the logs generated on my Windows machine, and using the universal folder, which is deployed on my local machine, to forward the logs to intermediate forwarder 1 and 2. So to do that, what we need to do, we need to deploy the Windows add-on that we will need to download from Splunk Base. So this is the first case that we need to do. Now, to do that, obviously, we need to go to Splunk Base and download that app. But before we do that, we need also to go ahead and create the index windows on my indexer 1, because obviously we're going to forward whatever we're going to be monitoring in here to our indexer 1. Now, let's go ahead and first do that. So what I'm going to do, I'm going to go to my indexer 1. So let's go 8,000. Let's log in. Now, let's go to settings, indexes. I will go ahead and create a new index, and I'm going to call it Windows. Of course, you can go ahead and set the size of this entire index. It's really up to you. I'm going to leave it as it is, and then I'm going to save it. So now the Windows index is enabled, and you can see in here. So then I'm going to go ahead and search for the Windows TA. And this is the one. Let's click on this one. Let's download it. I have accept, sharing, it's fine. Okay. So this is the app. So I'm just gonna copy this app. I'm gonna paste it in here for later use. So let's leave it as it is. So now let's go back again to our diagram in here, and let's discuss the other use cases. So remember, we will need to deploy the Windows add-on on this universal folder, which is deployed on my Windows machine using the deployment server. Now, let's move ahead to the second use case. So here I have a universal forwarder deployed on my Linux machine, and I would like for this specific use case to use the Linux TA, and we will activate some stanzas on this TA to monitor certain files and directories on my Linux machine and forward the logs to intermediate folder 1 and 2. So obviously, what we need for that also, we need to create an index Linux on my indexer 1 so we can ingest and write that data into disk inside indexer 1. So first, we will need to create the Linux index in here. And as a second step, which is part of the onboarding, we need to go ahead as well and download the Linux add-on. So let's go ahead and find that, which is this one. So let's download this one as well. So I have downloaded it. Let's copy it to my directory of apps, which I'm going to be using it later once I will move those apps to my deployment server, because I'm going to use the deployment server to actually deploy those apps and add-ons to the deployment clients, which are the universal forwarders in this case. So let's go back to our lab diagram. And now I'm going to use a custom app, if you remember from the previous sections, where I'm going to leverage some scripted inputs inside the Splunk add-on for Unix Linux to collect some OS level commands and then forward those logs to indexer 1 as well. Now, for this specific case, also I will need to create an index, and I'm going to call it Linux _ system, and I'm going to create it under indexer 1. So moving ahead, let's take the fourth use case in here, which is I have a FortiGate firewall, and I would like to configure this FortiGate firewall to forward the syslogs messages via port maybe 514 by default, or I could also customize it and use maybe 5555. And I'm going to use the heavy forwarder as the collection for these logs, and then I'm going to instruct this heavy forwarder to receive those logs and then forward those logs to indexer 2. So for this specific use case, what I would need to do as well, I will need first to create an index in here, and I'm going to call it Fortinet. At the same time, we already have an add-on, basically, to handle and parse the FortiGate firewall logs. So let's go ahead and do that as well. So on Splunk base, what I'm going to do, I'm going to type FortiGate. Let's examine that. And I actually have a Fortinet FortiGate add-on for Splunk. And I'm just going to download this one as well, because this is offered by Splunk, and we can use it basically so it can help us to parse the logs which are generated from the FortiGate firewall. So I'm going to copy this one as well, and I'm going to paste it in my apps directory. So let's go ahead and paste it as well in here. Now I have identified that we would need the Windows TA, the Unix Linux TA, and the FortiGate for our use cases. So let's go back to the diagram in here. Also, if you remember from the previous discussions, we've already configured the HEC. So what I'm going to do, I'm also going to create an index for all the incoming traffic for the HEC, and I'm going to create it under indexer 2. So if we go back to our notes, I'm also going to create an index, which is the HEC index, and I'm going to place it on indexer 2. So let's go ahead and start with those. So first, I'm going to create the Linux index. So let's go to my indexer 1. I'm going to go ahead and create the Linux index. I'm going to leave everything as default. I'm going to save it. Now I have the Linux index, which is also enabled. And then I'm going to create also the Linux system index for my scripted inputs. So let's go ahead and create that. So I'm going to paste it in here. I'm going to save it. So now I have those 3 indexes enabled on my indexer 1. Now, as per our requirement, what I'm going to do based on my notes, I also need to create the index Fortinet and the index HEC on my indexer 2. So let's go ahead and log into our indexer 2. So let me copy the public IP, 8000. Let's log in. Now I'm going to go to settings, indexes, and I'm going to create my index Fortinet for our 4th use case. Save it. I'm going to create another index, which is the HEC index. I'm going to save it. So now you can see that I have the HEC index enabled, as well as I have the Fortinet index enabled. So let's go back to our diagram. So now that we have identified what kind of indexes we want based on our use cases, what I'm going to do, I'm going to go ahead and first deploy the Windows add-on on my Windows machine. Now, to do that, what I need to do, I need first to copy those add-ons, and I'm going to use WinSCP to copy those to my deployment server. So let's go ahead and connect to my deployment server via WinSCP. So here, I'm just going to save it and I'm going to log in. Yes. Now I am located under OPT Splunk HC deployment apps. So I'm just going to copy those 3 add-ons to here. And now I'm going to go ahead via SSH and connect to my deployment server. So let's cd to opt Splunk etc deployment apps. And now I have here my Fortinet, my Splunk add-on for Microsoft Windows, as well as the Splunk add-on for Unix and Linux. So what I'm going to do, I'm going to untar those three. So sudo tar -xzvf Fortinet. So this is the first one, and you can see it's here. And I'm going to do the second one, sudo tar -xzvf, and then Splunk for Microsoft. And then let's do for the third one, so sudo tar -xzvf Splunk for Unix, and tar it. So now we have all three untarred. So what I need to do, I just need to delete those three. So sudo remove, this is the first one. Let's do the second one, sudo remove dash Splunk add-on for Microsoft. And I'm going to do the third one. So basically now we have those three. What I'm going to do, I'm going to change the ownership, of course, of those. So sudo chon -r Splunk, and then I'm going to do opt Splunk etc deployment apps. So now we have changed the ownership of all those three TAs. Now that we are done in here, let's go to our deployment server via the web. So it should be actually not this one, this one. So let's go to our apps. Let's do a refresh. And now we have those TAs reflected correctly in here. So the first use case that I'm going to be doing is I'm going to deploy the Windows TA on my local Windows machine where my universal folder is installed. Let's go ahead and do that. So let's go to the folder management. Let's create a new server class. So a new server class, and I'm going to call it Windows TA. Save it. Let's go to my Add Apps. In this case, I'm going to use the Splunk TA for Windows. Save it. And I'm going to use my client where I want to deploy this app to. And I'm going to be choosing my desktop 4L681NN, and this is my local machine. So let's do a preview. So there's a check mark in here. So let's save that. And let's do an edit to also trigger a restart of the Splunk daemon. So now let's wait. Let's see. Now I see that the Splunk TA Windows is already deployed 100% to my desktop. So what we can do, we can verify this by going to our search. And believe me, we're not going to find anything, and I will tell you why. So let's do index Windows. Why? Because if you remember from the previous slides or lessons, you also need to go ahead into the Windows TA and you need to do some changes to the configuration, because you need to specify as well the Windows index in there. And to do that, let's go back to our deployment apps. Let's do cd to Splunk TA for Windows. Let's do that, lslh. And let's go to the local, cd local. Let's see what do we have in here. So we need to do zoo Splunk. Now cd to local. Let's examine what do we have in here. Nothing. So what we need to do, as a best practice, it's always advised not to change anything under the default. So make those changes into the local directory. So what we can do, we can go back to our default, and then we can copy the inputs.conf from here and paste it into under the local directory. So what I'm going to do, I'm going to do copy -r of the inputs, and I'm going to paste it under opt Splunk /etc deployment apps Splunk TA for Windows under the local. So we have done that. Let's go one directory up and let's go back to our local. And now we have the inputs. So let's examine the inputs and let's make those changes. Inputs.conf. Now in here, what I would like, if you remember from the previous lessons, I would like actually to monitor the win event log for application. So I'm going to change that to 0. So I'm going to activate it. But also, if you remember, we have already specified the index Windows under the indexer 1, and we need to also specify this in the inputs.conf. So let's do that. What I'm going to do in here, I'm going to add index equal to Windows as the destination index for the monitored logs that I'll be collecting from here. Let's go further down. I'm going to do the same in here as well. So do 0. And I'm going to include as well my index equal to Windows. For system level logs as well, I'm going to activate it. And I'm going to add also the index equal to Windows, which is the one that we've created earlier under the indexer 1. Now for forward events, I'm not going to do that. Let's move ahead. Directory services, no. Key management, DNS server, no. DHCP, no, we don't need that. Maybe Windows update. Let's do that as well. Let's keep it to 0. And then index equal to Windows. PowerShell, it's up to you. You can enable that or not, but for the sake of this demo, I'm not going to do it. So let's move ahead. Scripted inputs. Yeah, listening ports. Yeah, we can do that. So let's change that to 0. And let's include the index Windows in here. Installed apps. I'm not going to do that. Time sync. Net address. No. Let's move ahead. So health and topology information NT6, no. Let's move ahead and examine the other monitoring input stanzas in here. So no. Host monitoring, yes. Let's actually enable that one. This is a scripted input. So enable that and then include the index Windows. This is going to run on a time interval of 5 minutes. So actually 10 minutes because it's 600. 10 times 60. So in the Win host as well, I'm going to include that as well here. So index equal to Windows. And I'm going to activate it as well. Processes, yes, definitely. Index equal to Windows. I think this is enough. So let's save that. Let's make sure that the ownership is Splunk. Yes. Now let's deploy this TA again. So let's go to our folder management and let's go back in here. So what I can do actually, we can reload the app. So all the apps that we have under the deployment apps, which are here, we can reload them. So let's do that. Bin Splunk reload, deploy server. So the reloading of the server classes has been done. Now let's do a refresh. Let's wait for a while. So now that we have reloaded our server classes by running this command, so let's go ahead and do a refresh. So let's go now to our search head and let's examine if we're actually receiving anything on the index windows. So now we have successfully deployed the Windows TA on my Windows local machine, which is this one in here. And we have made some changes to our Windows TA by copying the inputs.conf from the default directory to the local directory, which is regarded as a best practice. Never touch the default, always make the changes under the local, because the local directory takes precedence over the default directory. And now we can see actually the logs in here. So now we are done with the first use case, which is this one. Let's go ahead and actually deploy the Linux TA on the universal folder, which is deployed on this Linux machine. So to do that, let's go ahead to the folder management again. Let's go to server class. Remember, I'm not going to first deploy the Linux TA, because first, as we have done that on the Windows TA, we need to make some changes to that TA. So you remember that we have named our index Linux on our indexer 1. So we need to make sure we include that in the Linux TA. So let's go ahead to our deployment server and examine the Linux TA. So cd opt Splunk etc deployment apps. Let's check the different apps, and this is the app that I'm going to be changing the configuration to. So cd Splunk TA nix. Now we have the default, and let's make sure to create first the local directory. So sudo make directory local. And now let's go to the default and copy whatever we have under the inputs to the local. So cd default. I'm gonna go to the inputs.conf. So copy sudo copy -r inputs.conf to opt Splunk etc deployment apps Splunk TA nix and then local. So let's move one directory up and let's go to the local now. We have the inputs in here. So sudo nano inputs.conf. Now in here, what I'm going to do, I'm going to leave the scripted inputs and I'm going to actually check if we have some monitoring stanzas in here. So let's examine. So these are scripted inputs. Still scripted inputs. Yeah, monitor. So I'm gonna change that one. So I'm gonna put 0, and I'm going to include here the index Linux. Here as well, 0 and index equal to Linux. Let's move ahead. Monitor etc. I'm not going to need that anyways. Bash history. Yeah, we can do that as well. So false. And then index equal to Linux. Let's examine the other stanzas, what we have. Again, I'm going to leave the scripted inputs because we're going to deploy those to our next use case. So these are all scripted inputs. Yeah. So let's go ahead and save that. That should be okay. Now remember, don't forget to change the ownership in here. So sudo chon -r Splunk to the local. Hit enter. And now what I'm going to do, I'm going to go ahead. So now that we have the Linux TA ready, let's go and create a new server class. I'm going to call it Linux_TA. So let's save that. So now I'm going to choose the Splunk TA for Nix. Save it. Add clients. Of course, in here, I'm not going to deploy it to all my universal folders. So maybe I could deploy that to universal folder 2. So let's do that together. So let's go back in here. This is the universal folder 2. So what I'm going to do, I'm going to copy this, paste it, and I'm going to put a star for wildcard. So let's review. And here you see. So there is a check mark in front of it. So let's save that. Let's edit it. And let's trigger also a restart of the Splunk daemon. So let's click on the TA, and you can see it has been deployed. So now what we need to do, we need to go to the search head to verify we're actually receiving anything at all. So let's check that. It's going to take a while, but let's give it a moment. And as you can see now, we have verified as well that we're receiving the logs from our universal forwarder 2, where we have just deployed the Linux TA 2. So basically, this one. So we have successfully done that for the Windows, for the universal forwarder 2 as well. So now what I'm going to do, I'm going to deploy the same Linux TA to the universal forwarder 1, but I will make some changes to that Linux TA. So basically, I'm going to create another TA, this one, but I'm going to just activate some of the scripted inputs, and I'm going to deploy it only to my first universal forwarder. So to do that, I'm going to do sudo copy -r Splunk TA Nix, and I'm going to name it maybe Splunk TA Nix _scripted_ inputs. So now we actually have a new TA, which is this one. So let's examine that. So cd to Splunk TA Nix scripted inputs ls/lh. Of course, I need to go to the local now. So cd local. So now I'm going to do sudo nano inputs.conf. In here, I'm going to do enable this one. And I'm going to put index equal to Linux_system. Now, if you remember from the previous section, I have created the index Linux_system under indexer 1, and we have discussed that this one is going to be only for system level logs, which are going to be generated as a result from running these scripts. And this is exactly what I'm doing. So let's go to the PS metrics. 0, index equal to Linux underscore system. Let's check the other ones. Maybe interfaces, that would be a good one. So index equal to Linux underscore system. Let's check the other ones. Maybe CPU, that would be a good one as well. 0. So index equal to Linux underscore system. vmstat, no. Let's check the PS. Yeah, this one would be okay as well. So let's include the index Linux underscore system. Top, that would be a very good example. Index equal to Linux underscore system. So basically these TAs is going to make our life a lot easier because it's going to facilitate the onboarding of the data and you have already everything parsed correctly. But of course, there are some scenarios where you don't have a TA in Splunk base. And for that case, we will need to actually do the onboarding and the parsing of the data manually, which we will do it in our next section. So let's do index equal to Linux underscore system. So I think that should be enough. Let's save that. Let's do check that. Of course, we need to go in here and let's do sudo chon -r Splunk opt Splunk etc deployment apps. So I'm making sure to change the ownership of my directories. So you can see now it's Splunk. So now that we have our add-on ready, let's go to here under the forwarder management and let's deploy this add-on to our first universal forwarder, which is this one here. So let's delete that and let's create a new server class. So I'm going to call this one Linux underscore TA underscore scripted inputs. And this is destined only for Universal Forwarder 1. So let's save it. Let's add the app that we have just created. So scripted inputs, that's the one. Save it. Let's add now the client, which is the UF1. Of course, the UF1, if you remember, I didn't name it correctly, and it should be this one. So let's copy it, paste it, preview, save that. So now let's do an edit to trigger the Splunk restart. Save it. Let's go now to our next scripted inputs, and you can see it has been deployed successfully. Now to verify if we are receiving anything, let's go now to our Linux underscore system, and let's check if we are actually receiving anything at all. If you remember, this is a scripted input which runs on intervals, so we need to give it some time, and here you go. So you see that we are now receiving the logs from our Universal Forwarder 1. So in this section, I will go ahead and configure the heavy forwarder. Now, first things first, what we need to do, we need first to actually deploy the deployment client on this heavy forwarder so it can phone home back to the deployment server. And we can use the deployment server as a centralized tool to deploy whatever apps and add-ons back to the heavy forwarder. So let's log in to this heavy forwarder via SSH, and let's do that. So cd opt Splunk etc apps. And now in here, we need to copy this app here so it can talk back or phone home back to the deployment server. I can use WinSCP to copy this file. So let's go ahead and log in via WinSCP to the heavy forwarder. So to do that, what I'm going to do, just going to open a new session, basically. And I'm just going to go to my heavy forwarder and take the public IP address. So let's go back in here. So paste it. And I'm going to provide the username and password. So now I'm on the heavy forwarder. So let's go to the temp directory in here. And let's copy the deployment client app. So let's paste it in here. So now it's here. So let's go back to the CLI. Let's cd to temp. And I have it in here. So let's do sudo copy -r demo to opt Splunk etc apps. Let's switch to the apps directory. So opt Splunk etc apps. Now let's check that app, which is this one. Now what I'm going to do, just going to cd to the demo, then local, then I will do a sudo nano deploymentclients.conf. I need to change, of course, the IP address in here to reflect the correct IP address of my deployment server. So let's go to the deployment server and copy the private IP address. So let's go back in here, paste it, Control X, save the settings. So now let's go ahead and change the ownership of the file to Splunk. So opt Splunk etc apps. Now let's trigger a restart. So sudo -u Splunk bin Splunk restart. So let's wait for this to finish. So now, once we are done restarting our heavy forwarder, then we should go back to our deployment server in here. So we're going to be able to actually see it. So let's log in to our deployment server. Let's go back to the forwarder management. Let's go to clients. Let's wait for a minute. So now we're actually able to see also the heavy forwarder. But of course, under the heavy forwarder, we don't have any apps deployed to it. So what we need to do, let's go back to our diagram in here. I will need to deploy the FortiGate TA. So it's gonna help us to parse the logs, which are incoming from this FortiGate firewall to here. Also, what we need to do, we need to create another app on this heavy forwarder so we can instruct it to listen on port 5555 or 514. We will see. In addition to that, we need to create another app so the heavy forwarder can forward the logs to indexer 2. So let's do that together. But all of this will be done solely from the deployment server. So let's do that. Now let's log in to our deployment server via SSH. So let me just copy the public IP address of the deployment server. Let's go back to our heavy forwarder. Let's exit and let's paste the IP address and let's log into our deployment server. So let's go to OPT Splunk etc deployment apps. Now in here, I will need to copy the same app, which is this one, to instruct the heavy forwarder to listen on port 5555. However, this app is configured to listen on port 9997. What I'm going to do, I'm going to duplicate this app and then make the changes. So let's do copy -r demo lab inputs base, and I'm going to rename it to demo underscore lab underscore inputs underscore heavy forwarder underscore FortiGate. So let's do that. I forgot to include the sudo. So sudo. Now let's go to our demo lab inputs, then heavy forwarder. Now let's do sudo nano local, then inputs.conf. Now let's change that port to 555, as well as instead of Splunk TCP, I'm just gonna put UDP. And also we need to include the index, which is gonna be the destination for all this traffic on Fortinet. So Fortinet index, because if you remember, we've already created the Fortinet index on our indexer too. So we need to make sure that this has to be tagged into the inputs.conf inside the heavy forwarder. So index equal to Fortinet. Now let's save that. And now let's do sudo chon -r Splunk opt Splunk etc deployment apps. So now let's go to deployment apps. I have just created now the inputs to prepare this heavy forwarder to listen on port 55555. So now let's duplicate another app, which is the demo lab underscore if underscore outputs underscore base, which is instructing basically those intermediate forwarders to forward the logs to the indexer 1. However, we're just going to make some changes so that instead of going to indexer 1, it's going to go to indexer 2, but we will deploy it to the heavy forwarder. So let's do that together. So let's go back to our CLI. Let's do sudo copy -r demo lab if output base, and I'm gonna rename it to demo underscore lab underscore heavy forwarder underscore outputs. So let's go to that app. So cd demo lab heavy forwarder, and I'm gonna do sudo nano local and then outputs. And now I'm gonna change it to indexer 2, and I'm gonna put the IP address of the indexer 2. So what I'm doing here, I'm just gonna reuse the same app that I have deployed for the intermediate forwarders and just change some configuration so I can deploy it to the heavy forwarder. So let's go back to our instances and let's go to indexer 2. And I'm just gonna copy the internal IP address of the indexer 2. I'm gonna paste it in here. I'm going to save it. Just going to move some directories above. So sudo chon -r Splunk, then opt Splunk etc deployment apps. So let's go to the deployment apps. So now I have prepared the outputs, so the heavy forwarder outputs, where I'm going to instruct basically this heavy forwarder to forward the logs to indexer 2. I'm going to deploy as well the demo lab inputs heavy forwarder FortiGate, where I'm going to instruct this heavy forwarder to listen on port 5555, as well as I'm going to deploy the FortiGate TA that we have done earlier throughout this lab. So let's do that together. So what I'm going to do, I'm going to go to the forwarder management now. I'm going to create a new server class, and I'm going to call it heavy forwarder base. I'm going to save it. And I'm going to add all 3 apps together. So that would be the Splunk TA, because we will need that there, as well as the demo lab inputs heavy forwarder, where I'm going to activate the heavy forwarder to listen on port 5555 for incoming traffic from the FortiGate firewall, as well as I'm going to instruct the heavy forwarder to forward the logs to indexer 2, which is this one. So I'm going to save it. And I'm going to add the client, which is the heavy forwarder, where I intend to deploy these apps to. So let's copy, for example, this one. Let's paste it in here and put a wildcard. Let's preview that. So I already have a check mark. So let's save it. So now let's do an edit on maybe this one. Should be okay. I'm going to trigger a restart of the Splunk daemon on the heavy forwarder. So now that we have deployed all those 3 apps to the heavy forwarder, that means we can verify this by going to the CLI of the heavy forwarder. So let's go to our heavy forwarder. So exit. And let's copy the IP address of our heavy forwarder so we can SSH to it. So this is the IP address, 100. So this is the one. Let's log in. So cd opt Splunk etc apps. So let's do lslh. And now, as you can see, we have all those 3 apps that we've just deployed from the deployment server, and they have landed under Splunk etc apps. So now that we have configured our heavy forwarder in here, so let's go ahead and actually configure the FortiGate firewall to forward the logs to the heavy forwarder. But before we do that, we need to make sure that the port 5555 is opened on the inbound. So for whatever logs they're going to be sending from the FortiGate, we need to make sure that that port is opened. Now to do that, let's go to our instance under our heavy forwarder, and let's check if we have a security rule in place. Now in here, I don't see any security rule. So what we need to do, we need to go ahead under security groups and create a new security group for this. So I'm going to call it FortiGate incoming traffic. I'm just going to copy this and just going to paste it in here. And I'm going to add a rule on the inbound. So it's TCP 555. I could also actually include TCP and UDP just in case, but let's include the TCP. And then from everywhere, And then I'm going to add another rule for actually for UDP. So let's also include the 5555. So now let's just add anywhere. So now let's create the security group. Now let's go back to our EC2 instances. And now let's go to our heavy forwarder in here and add that security group. So under security, change security group, and I'm going to add that group, which is the FortiGate incoming traffic. So let's add that. Let's save it. So now let's go ahead to our FortiGate firewall and configure it to forward the logs to our heavy forwarder. So let's log in. So config log syslog settings. Now let's do set port 5555, set mode UDP. So let's do show. Now we need to set the port 5555. Let's do a show again. And we can see that it's enabled, and this is the destination IP address of our heavy forwarder. So let's do an end. So now let's go back to our diagram and discuss this. So I have already configured the FortiGate firewall to forward the logs to the heavy forwarder. Now to verify this, we need to go ahead to our search head and check if we are receiving any logs from the FortiGate. So now I'm actually able to see the logs coming from my FortiGate. So now that we have deployed our Splunk environment in this lab successfully, now comes the interesting part, which is the data onboarding process. You see, the data onboarding workflow consists of a few steps. So let's jump ahead to our slides and let's discuss that briefly. In the real world, whenever you're facing the customer, it's always good to ask the customer upfront and let them prepare kind of a list of all the data sources that the customer wants to ingest. So you can ask the customer, for instance, what is producing this data? Is it an application, an appliance, and where is this data residing? Is it a flat file? Is it coming from a syslog feed? Is it this data being generated from a REST API? Is it a database? Or simply maybe they want to monitor their Windows end machines, and then you want to deploy the universal forwarders to these end machines. So ask for more specific information, such as let them prepare kind of like a sheet to put the data source host names, the IP addresses, the path to this data, the location, the access information. And at a later stage, maybe you could also ask them about the retention requirements, like how long this data needs to be kept on the database. So let's jump to our next slide and discuss that. So again, gather information about the data sources, where is this data, and kind of define the data collection methodology. So let's jump back to our lab diagram and discuss that. So there are a lot of customers where they already have kind of a syslog server, and they're actually forwarding all their logs from their end machines, like firewalls, proxies, etc., and they are being collected in a centralized server. So what you can do, you can actually deploy the universal forwarder or the heavy forwarder to this centralized syslog server, and then you can instruct it to forward the logs to the indexing tier. And this is exactly what we are simulating in here. So now let's jump back to our slides and let's discuss the next points. Now, once you have gathered information about the data to be ingested, it's always advised that you go ahead on Splunk base and check if there is a pre-existing app or add-on for that data. This is going to make your life a lot easier. And this is exactly what we're going to do throughout this lab. Now, in case that you don't have any add-on or an app for a specific data that the customer wants to ingest, you can always revert back to the data previewer and use the props and transforms to get this data parsed correctly. And this is exactly what we're going to be doing. So let's go to the next slide. Things to remember. Try to set the source type at the beginning. It's always advised that in the input phase, try to configure the source type. In case that you are not able to define the source type, in case that you cannot define the source type, then you can always use the props to do that job for you. So basically, you can put this control in the props.conf and you can define the path to the source, and then you can set a value for the source type. Same as well for the host. Now, if the source type is set at the input phase, you cannot override it in props.conf. So make sure you satisfy this requirement. Now, you can configure the source type with additional controls to get this data right at parsing phase, like setting up the line breaking, the timestamp extraction, raw data manipulation, and field extractions, and many more. So let's identify the different controls in props.conf. So here you have the should line merge. So by default, the should line merge is always set to true. Now, the should line merge, when it's set to true, Splunk will combine several lines of data into one single event. Now, in the real world, and as a best practice, always set the should line merge to false and let the line breaker do the job for you. So you should actually rely on the line breaker in here to break your data into events, because there's a significant speed boost by using this line breaker instead of relying on the should line merge. So turn this off, always advised. Now we will use the time prefix. So the time prefix is just a regular expression that is going to serve as a starting point to help the Splunk software to extract the timestamp in that data. Of course, the max timestamp look ahead is just to tell how much to look into the data for the timestamp extraction. Now, we will actually implement all of these controls in the props.conf in our next demo lab. So one of the most important steps of data onboarding is to get your data parsed correctly. And to do that, we can use the data previewer in Splunk Web. But before we do that, let me show you a sample of the data that we would like to parse. So you can see here, this is the data. And from the first glance, I can see that maybe we can use this part to get our timestamp extracted correctly, or we can also use this part. Also, if I take a deeper look into the data, I can see that this is a source IP. This is the source MAC address. This is the destination IP, destination MAC address. And I can see a lot of fields which could be of interest. So I will show you how we can extract all these interesting fields. So before we go and upload our sample data, what I tend to do normally is to create a new app context where I can keep track of all the configurations that I'm going to be implementing. So let's go ahead and create an app. And then I'm going to call it demo-lab. I'm going to name it as well, demo-lab in here. And I'm going to put the version 1.0.0, visible, yes. The author is me. Let's save it. So now that I have created it, it's showing in here. So let's go ahead to our Splunk web. So let's go to settings, add data, upload the data from here. Let's select the file. Let's upload our sample data. So now we have uploaded the data and you can see it in here. So let's break down for you the different controls that's going to help us into parsing this data correctly. So let's start with the character set. You can leave that to UTF-8 by default. Leave this one as it is, or we can just delete it. Now, as previously mentioned, for the should line merge, it's always advised to set it to false. Now, we can rely on the line breaker in here, which is going to tell Splunk software where to break the data into events. So this is going to help us to define the event boundaries. So if you go to this page, under Advanced, you can see here that this regex pattern help break the data into an event for each line. So let's copy some of this data. Let's put it into our regex 101. Now let's go back in here and copy this regex pattern and let's paste it in here. Now, what we want to achieve in here is to break the data exactly at the end. So we can start with a new event. So to do that, I would highly recommend to watch some videos out there for regular expression. So what I'm going to do, I'm going to escape and I'm going to put a square brackets and then another escape, which is a backslash, and then a double quote. So you can see now that we are breaking exactly at the point where we want. So this regex is going to help Splunk identifying the event boundaries. So let's copy this one. Let's go back in here. Let's paste it. Now let's apply. Raw, and you can see it's breaking down correctly. Now, if I'm going to add just another double quote and apply in here, you see now the data is not parsed correctly. So if I delete that and apply it again, you can see that Splunk is identifying where are the event boundaries of the data. So let's go back and create a new control. So if we go back to our slides in here, we can actually copy the time prefix. So let's copy that. Let's go back here and paste this control. Now the time prefix here, I want to actually tell Splunk where to start to look for the timestamp. I'm not going to rely on this one. I'm going to actually rely on this one. So what we need to do, let's go back to our regex in here. Let's delete this part. And I actually want to start to look for the timestamp starting from here. So I'm going to put a backslash, then a double quote, then time stamp, which is an exact match, a backslash, and then a double quote, a backslash, and then a colon, double colon, and then another backslash, and then a double quote. So I'm just going to copy this one. So now I'm telling Splunk to start looking for the time exactly at this point. So let's go back to our data previewer. Let me paste that. So if I'm going to do apply settings, you see, so now we are telling Splunk to start looking for the timestamp starting from here. Now let's create a new setting. And let's go back to our slides and let's copy this one. So let's paste it in here. Now this works in conjunction with the time prefix. So with this control, I want to tell Splunk on how long I want to look into the timestamp. So these are 4 characters, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So let's put 20. Now, let's go back to our slide, and I'm gonna copy the time format. So let's add a new control and paste it in here. Now, the time format, this is on how to format our timestamp. So if we go back to this one, these are the time variables that we can use to format our timestamp. So to do that, let's check our timestamp here. So this is a 2018. That means we need to choose the year format, which should be something like, let's take a look, which is this one. So let's copy this one. So let's paste it in here. Then I have a minus. So let's put the minus. And then the month is 08, which is August. So let's go back in here. So let's go under specifying the months, which should be of this format. So let's copy this one. Let's go back to our data previewer. Now, the day is 20, which should be of this format. So let's first put the minus, and let's go back to our variables in here. So specifying days and weeks. So for the day is of this format, which is correct. So let's copy this one. Let's go back in here. Let's paste it. Let's take a look. There's a T, capital T. So let's copy that exactly as it is. And in here, you can see this piece or this portion. It's the hour, minute, and second. And this is the format. So let's go back to our documentation in here, and let's take a look at the variables of the hour, minute, and second. So if you see here, this is the hour, the 24-hour clock, which is from 00 to 23, which is exactly what we want. This is the 15. So that means I'm going to copy this one. Let's go back to our data previewer. Let me just paste it. There is a colon in here, and then for the minute as well, and for the second. So let's copy the one for the minute, which is the decimal number from 00 to 59 format. Let me copy that. Let's go back to our data previewer. There is another colon. So let's go back and check the seconds, which is also a decimal number. Spend some time in here and identify all the different variables which are crucial to the time format. So let's go back in here. Let's paste it. Let's apply the settings. And as you can see, we are actually telling Splunk to look only for the first 20 characters or positions, starting from this point where we have used the time prefix. So now that we have the data correctly set up, let's go ahead and save this source type. So I'm going to name this source type as demo-lab. Let's leave the description, and then I'm going to change the app to the one that I've created earlier throughout this lab, which is demo-lab. So let's save it. So now that we have parsed this data correctly right now, let's go ahead and click on next. Now I'm gonna place it under the main index. Let's preview, let's submit. Let's wait for the data to be uploaded. So now that I have identified the timestamp as well as the event boundary of this data, and I have broken it down into events, let's go ahead and click on Settings, Fields, so we can extract some fields of interest for us. So let's click on Field Extraction. And now I'm going to click on Open Field Extractor. And I'm going to select the source type, which was Demo Lab, if you remember. Now I'm going to choose All Time in here. And I'm going to select a sample event, which is this one. So let's go and click on Next. And I'm going to use the regular expression. Let's click on Next. And now, if you remember previously, we have identified some fields which could be of interest to us. So let's examine this. Now, this is the first field, which is source IP. This is the IP address. So let's highlight that. Let's give it a field name, maybe source underscore IP underscore address. Let's add that as an extraction. So let's highlight this one, which is the source MAC address. So I'm going to give it a name, source underscore MAC address. Let's add it as an extraction. Now I'm going to choose as well this IP address, which is destination IP. So let me just give it a name, destination underscore IP address. Let's add it. And then you can do the same for this one, which is destination MAC address. And let's add that as an extraction. And maybe let's add another field, which could be maybe the protocol type. So let's add that as well. So I'm going to call it protocol underscore type underscore, maybe I'm going to call it proto underscore type, because we have already here a protocol type. So let's add it to the extraction process. So now I have identified those 5 fields. What we can do, we can also show the regular expression in here. Now, what I would highly recommend, always double check this work. Although Splunk is good in identifying and formulating for you the regular expressions in here, though it's better that you also do it yourself. So Control C, let's paste it in here. And you can see that we're actually getting a good match against all this data. So always verify the work. So now that we have extracted those fields from our sample data, let's go ahead and click Next. Let's now click Next again. And now this is going to live under my demo lab. So as you can see here, I'm under the demo lab context. So let's finish that. So now if we go to search and reporting and search our data, which is under the index equal to main, let's go under all. Let's pick the all time picker. And you can see here that we are not seeing actually the fields that we have just extracted. Why is that? Let's go back to our regex and take a look. So we have named it as source IP address. We have named it as source MAC address. destination MAC address, proto underscore type, and the destination IP address, but I cannot actually find that. Now, the reason why, because this is under the search context, and we have configured those field extractions under my demo lab context. So let's click on the demo lab, and under the demo lab context, and because of these are regarded as search time field extraction, so we need to make sure we go under the proper app context. So let's go to our index main again. Let's search for all time. And now we can see that the fields are now showing destination IP address, destination MAC address, source IP address, source MAC address, and also the prototype. So this is how it's done. So now that we have parsed our data and we have defined the event boundaries and we have also done the time extraction and some field extractions as well, let's take a look at the props.conf and how it would look like. So let's go ahead to our CLI and let's take a look at the props.conf. Now you can see this is the source type under the props.conf, and this is the line breaker that we have defined, the should line merge set to false, and this is the time format that we have configured and the time prefix. And you can take a look as well at the extract, which is another control that's going to help us to do some search time field extraction. And you can see these are the different fields. And if we go further, you can see as well all of the regex pattern and the capturing group for these fields that we have defined in the web. I will provide basically all of these configurations under the resources. So now there's another command which I think it's useful, which is the zcmd command. So let's create one. So let's go back to our props.conf configuration and let's take a look at that. Now, this is the command setcmd, and now it's used only at index time. It's commonly used to anonymize incoming data at index time, such as credit cards, social security numbers, etc. Now, the way we will create this control, so let me show you that. So let's go back to our search. Now, let's examine the data. So for instance, I would like to anonymize the first or mask the first part or the first half of our source MAC. So how we would do that? So let's go back to our CLI and do that together. So the format would be something like setcmd. Let's give it a class name. I'm going to call it maybe test. Let's do equal. Now the format is as follows. So an S for substitute. And then here we will provide the regex match or the regex pattern. And then we will replace it with something that we would like to anonymize. So we can put here like a replacement. And then we can do \1, which is the capturing group, and then a / for a G, which means the global attribute. So let's do that together. Now let me just copy one sample event. Let's copy it. Let's go to regex. Let's remove this. Let's paste it. And let's remove all of this. Now, the way to do it, I want to only substitute this first part with maybe X's. So how can I do that? So let me copy first this part. Let me just paste it in here. Now I have highlighted this regex match. Now what I'm going to do, and I'm going to put a \W and maybe a plus, or actually what we can do as well a quantifier, maybe of 3, or that won't work. Maybe what we can do, we can add this, and that means I'm gonna do like this. So basically, what does that mean? If we highlight it, it matches a single character not present into the set. So now I'm going to use this substitute, the quantifier. I'm going to put maybe 2, 3, 4, maybe 5, actually 6. Yeah, so 6. Now I am actually matching all of this. So now what I'm going to do, I'm going to put a \W, or actually, I'm going to put 2 quotation marks, or maybe this one, then a dot, a star, and then maybe this one, and then I'm going to put the 2 quotation marks. So basically now I'm doing a capturing group in here. So I'm only defining this part. So now what I'm going to do, I'm just going to copy all of this. So Control-C. And let's go back to our CLI. I'm just going to paste it in here. I'm actually going to remove this part up to this point. And now I'm going to put /, and then I'm just going to copy this substitute or the replacement. So I'm just going to copy maybe this part and paste it in here. And then I'm going to put like XX:XX:XX \1/G. So let me explain. With this regex pattern, I'm catching all of this piece or all of this portion. And with this part, this is a capturing group, which I'm keeping. So this part. And I want to replace everything which is here with this part. And I'm keeping whatever I'm capturing in here with the capturing group and leave it as it is. So basically the end result will be the first part will be replaced with this, but I'm keeping the second part because I'm putting the one which is referring to the first capturing group here. So let's save that. And now what we need to do, we need to do a debug refresh. So let's go back to our search. So let's go back to here. Let me just copy this part, Control-C, paste it, and let's do debug refresh. Actually, before I do debug refresh, I almost forgot to check if Yeah, it's still Splunk, which should be okay. So now let's trigger the debug refresh. Let's wait. So now let's go back again and search our data. Actually, it's not going to work because I need to delete the data and do it again. So let's delete first the data because it's at index time, it happens. So we need to ingest the data again. So let's add the data one more time. So upload, select the file, which is the same sample logs. So let's hit next. Let's choose now the same source type that we've created earlier. And it's showing in here. Let's go for next. Let's go with the main index again, and let's do a preview and then submit. So now let's wait for this to finish. And then we can see if the masking of the data did happen correctly and successfully. So let's start searching. And as you can see now, actually, it has been anonymized. So this is how you can use the ZCMD control to actually anonymize your data. I would encourage you to go under the props.conf and read more about this. But this is how it works. Now, if we go back to our fields and under the source MAC, you can see that now the data has been anonymized. So let me just recap one more time. So basically the ZCMD, this is a Unix Z-like syntax, and it's used to search and replace. So basically this is the flag substitution here. Now, this is the regex match. So basically search for this pattern in your data, and whatever you're gonna place or put between brackets, this is gonna be a capturing group, which is gonna be replaced by this flag. So this is the regex match again. This is the part where you want to substitute with. So basically, whatever you're gonna capture as the first portion, substitute it with this part, and this part is gonna be referenced by the flag 1. So this flag 1 indicates the first capturing group, which is this one. So it means that we are keeping this portion, but we are replacing this portion with this portion. And this flag, this is a global. So in this section, I would like to do another data manipulation, which is, I would like, for instance, to overwrite our meta field, which is the host. So let's examine our data. Now here I have my data, and maybe what I can do, I can overwrite the host by the source IP address in each event. So how we can do that? So we can overwrite the host field here by the IP address of every single event with the help of props.conf and transforms.conf. So let's do that together. Now, let's go to our CLI in here and let's make those changes. So let's do cd opt Splunk etc apps. Let me do zoo Splunk, provide the password, and now I'm logged in as Splunk. So let's go to our demo lab app, cd to local, and here I have my props.conf. So I'm going to create another control in the props.conf. So let's do that together. So props nano.conf. So in here, I'm gonna reference the transform class. So let me just do that. So transforms dash, I'm gonna call it maybe host underscore change. Now, I'm gonna give it a name, host underscore overwrite. Now let's discuss that briefly by going to the Splunk documentation. So let me just copy this for a second. And let's go to the transforms. Actually, to the props. So Control F, Control V, this is the one. So the transform dash class. This is used for creating indexed fields, so index time field extraction. This is a unique literal string that identifies the namespace of the field you are extracting. So think of this class as an identifier to the transform set. While the transform stanza name, which is this one, this is the name of your stanza from the transforms.conf. So basically what we are doing, we are referencing the transform stanza name inside the props.conf. So we're gonna go ahead and call it from the transforms.conf. So let's go back to our CLI and let's make that clear. So here, this is the identifier for the transforms. So think of this transform set as a way to call the function inside the transforms.conf. So let's save that. Now remember, we have named the transforms stanza as a host underscore overwrite. So let's go ahead and create the transforms. So I have to declare first the stanza name, where I'm gonna be calling it from the props.conf, and this is the one. So host overwrite. And in here, we have regex as a control. We have dest underscore key, and we have the format. Now I'm gonna discuss those three briefly. Now, there is another one, but normally we don't declare it, but I'm gonna declare it for the sake of clarification, which is the source underscore key. Now, if we don't declare it, by default is gonna be set to the raw. So basically this indicates which data stream to use as the source for the pattern matching. So it pretty much means what is the data where I want to do the manipulation or the changes to. And by default, it's the raw data. So the regex, however, identifies the events from the source key that will be processed. So basically this is, think of it as a regex match that I'm gonna match against whatever I have into my raw data. Now, the destination key indicates where to write that change, which I'm gonna be capturing through the regex pattern. The format is how to write that regex. So let's go now and do the regex for our data. So if we go now to our search, let me copy some of the events. Let's go to regex 101. And now let's create a regex pattern to actually get the source IP, which is this one. So let's do that. So I'm gonna do backslash, and I'm gonna type source underscore IP, and then another escape, which is the backslash, another escape for the colon, and another backslash for the double quotation mark. And now in here, what I'm going to do, I'm going to open a capturing group, and I'm going to include the first IP octet. So -D, which is a digit, and then the quantifier from 1 to 3. And then I'm going to put a backslash and escape for the dot. And then I'm going to copy the same pattern in here 3 times. So paste, a dot, paste, a dot, and paste. Now in here, I have copied this, and I'm going to end it with a backslash and a double quotation mark. So basically now what I'm doing, I'm capturing what is inside, so the IP address in here. So I'm going to copy this regex pattern, and I'm going to go back in here, and I'm going to paste it under the control regex. So let me just copy this one again. So copy, let's go back to our CLI, paste it. Now the destination key, this is, since I want to do an overwrite of the host, so I need to include it this way: metadata, double colon, and then host. And the host indicates the host field, this one, because this is a metadata field. Let's go back to the CLI. Now the format would be host, double colon, and then a $, and 1. Now the $1 indicates the first capturing group, which is this one. So any regex pattern between brackets in here, that means this is gonna become a capturing group. So this is what we are doing basically. So now what I'm gonna do, I'm just gonna do save it. Let's make sure that it is Splunk. So what I'm gonna be doing now, I'm gonna do a debug refresh. Of course, this is not gonna work because this is index time field extraction. So I need to delete the data and do re-inject the data again. So debug refresh. Let's wait for this to finish. So the changes that we have done to the transforms and to the props will take effect. So now if I do a search, this is not going to change because I will need to delete the data first, and then I will need to ingest it again. So let's do that together. So add the data one more time, upload the data, select file, the same sample logs. Let's wait for it to finish. Let's do next. Let's select our source type, which is the demo lab. Now let's hit next under the main index, and let's submit the data. So now it's being uploaded. So let's start searching. Of course, there is nothing. So let's only go to our index main. Let's remove this part. And let's hit enter. Now we have actually overwritten our host, the previous one, with the IP address taken from here. So this is a good way or a good example on how to do data manipulation. Now, bear in mind that there was a mistake that I have done, and let me show you this. So before I said 2 colon Instead, you need to put only one colon in here. So thanks for watching.